Learn about serverless architecture and microservices with C#. This course is taught by Muhammad Abdullah, who is an Azure Certified Solution Architect. You will build practical skills step by step, starting from the fundamentals of serverless and microservices, then moving into real-world patterns like onion architecture and containerization with Docker. You'll build Azure Functions and triggers, plus background and IoT functions. You will learn to organize microservices with Kubernetes and Azure container apps. Security and observability are covered to prepare you for production. And a full case study project ties everything together.
Hi everyone, welcome to Practical Serverless and Microservices with C# course. My name is Muhammad Abdullah, and if you are wondering how to build modern scalable application without care about the server, the infrastructure, then you are at the right place. In this course, we will not cover the theory about the serverless and microservice, but we will do real world practical work. We will fix real business problem with serverless and microservices in C#. So if you are new to this channel, so please subscribe and hit the bell icon to get latest video about this course. So let's start this course. First, I will give you some introduction about the serverless. In serverless environment, we don't care about the infrastructure. Developer only focus on the business requirements and not managing the server. So serverless promise you a build and run application without managing infrastructure. The cloud provider like Azure, Google, AWS handle server allocation and provisioning. And next, the journey of the serverless is started in 2014 by Amazon. They first introduced the AWS Lambda, the first serverless solution. Then Microsoft introduced Azure Function in 2016, and presently also Google also provide serverless cloud functions. So in this course, we will only focus on the Microsoft Azure Function. Okay, so next step, why we choose serverless. So there is few reasons, few benefits, like it auto scale, like no manual scaling required, and the pricing model for the Azure for cloud is pay as you go. Only pay for what you use, and it's a reliable, secure, and we can only focus on the development, so we can do fast development and a sustainable growth. So this is the few benefits of using serverless. Okay, so serverless is equal to the microservices. So we will check this fact. Like in microservices architecture, each component is loosely coupled, independent component, and each component covers some business capability. And serverless is the way to build microservices architecture. So to deliver microservices architecture, serverless is the best option. So this is one example. For example, if you have an application, this is one microservices of that application, the user authentication. In user authentication, we will have like a registration function, login function, reset function. So these three components create a user. This is one example of the user authentication microservices. Okay, so next, Azure Function, launched by already covered 2016 by Microsoft. It's worked as a function as a service. And we can write Azure function any language like C#, JavaScript, Java. But in this course, we will focus on the C#. So Azure function also have a capability of integration. We can integrate Azure function with database, events, workflows, and third-party APIs. So we can easily integrate Azure function with these technologies. And there is some advanced feature if you want the stateful function. So you can use a durable function. We will see durable function in other upcoming videos. We can also build a CI/CD pipeline. We can monitor our Azure function, that we can diagnose, we can troubleshoot. AWS provide this, Azure provide this facility to us to create CI/CD pipeline. We can get logs and troubleshoot any problem in the Azure function. So when you create Azure function, you will select hosting plan. So this is some consumption-based flex information about the hosting plan, like consumption. It's work for event-driven workload, it auto scale and cost effective. So in this course, we will use mostly the consumption because it's a true serverless. You can also use, if you have containerized application, you can use a container app hosting plan. It's up to your requirement. So this is some information about the hosting. Benefit, no infrastructure management, it auto scale and pay as you go model and fast development. Already mentioned in the beginning. Okay, you can use any language for to write Azure function. Each rich ecosystem and secure DevOps also supported. So for this video, you will first create Azure account. You will set up Azure account. You can write Azure function, any of your favorite IDE like Visual Studio, VS Code, and you will first initially, if you go in VS Code, you will initially set up Azure core tools. So we will create Azure function using the Azure portal. You will see how we create the Azure function. So first you will create Azure account in the portal.azure.com. Once your account is approved and created, so you will see you will create these resources from Azure. For example, in this video, we'll focus on the Azure function. So to create Azure function, you will search for Azure function. So you can see here Azure app. So first we will create Azure app, like this is the Azure app. So we will create on the create. So you can see here, this is the hosting plan as I mentioned in the slides. We have flex consumption. It's for fast event driven consumption base. It's for event driven workload. Functions premium also for event driven. This is the some like matrix. So it's up to you which hosting plan suits your requirement. If you have a containerized app, so you can use the container app environment. So this is a different workload, different hosting plan. For we will select the consumption because it's a true serverless, and we will use consumption in this video. So you will select this, and the pay model is pay as you go model, reward for the consumption. So select. So you will, in the basic setting, you will select the subscription. You will create any subscription. Currently I have one subscription, and then you will create a resource group. Resource group is important. For example, for this course, I created one resource group. This is the resource group. You can see here serverless and microservice course. So each and everything we will keep in this resource group. We will check their billing. We can manage each component of resource in any resource group. So how you can create if you are new to Azure, then how you will create the Azure resource group. So this is a Azure services. So you can see here, you can also search resource group here, resource group. So this is the resource group I already created for other application. Now you will create this create button, and you will select this your subscription. Then you will give any name to this subscription. It will be, for example, project A, B, C. So you will give this name. You can select nearest region to your project or application user. For example, I will select Southeast Asia, and then next you will review and create. So when you create, we click on this create button, the resource will be created. So I will not create again because I already have resource group. So once you create this resource group, then when you come to this basic setting, you will see the newly created resource group in your list. So I have already serverless and microservices resource group. So I will select this. Now next, you will give one globally unique identifier for this function app name. So you can your first function app demo tool, for example. So this will be a unique identifier for your app name. After that, you will select the operating system. You will select window. If you are using Linux, you will use Linux. Next, you will click on this runtime stack. You will select runtime stack. Now I will use .NET. You can also use other Java. Yeah, you are using other in our technology, so it's up to you. This is the version of .NET. I will go in .NET 8, and this is the region. Again, you will select region which is closest to your targeted user. Okay, so next is the storage. So you can see here, basic one is completed. Storage. So Azure function need storage account by default. So you will, if you don't have any storage account, then you will create storage account. Okay, if you are new to Azure function, then how you will create Azure storage account? You will search Azure storage. Okay, storage account. You can see here storage accounts. So you will create storage account. You will click on the create. Okay, so this is basically one basic setting. You will select the resource group, and you will give name less microservices. So it should be 24 character, and for example, so yes, so this is available. Again, you will select a region. This is the primary service. If you use the storage for Azure file, you will select Azure file. If you want to use Azure Blob Storage, you will go with this. So this is optional. So next, you will create the performance. l- Like I will go with standard. If you need other scenario, low latency, for example, you will select the premium, but it will charge you. But so I will go with the standard. And this is the redundancy. You will I will go local redundant storage. If you need copies of your data to not lose your data, so you can use this option, like zone redundant, geo redundant, and this is different type of redundant account types. So for to use the low cost option, I will go with low redundant storage. Okay, so this is used for non-critical scenarios. If you want, for example, backup, so you can use geo-redundant. And if you want to use highly availability scenario, so you will go zone redundant. And if you have a very critical case, critical data scenario, so you will go geo-zone redundant. So this is different top redundancy tags. So I will go for with the redundancy. Next is another one is optional. We will keep it as default. Uh, so you will at the end you will review uh, the storage account, and you will click on the create button. So I already created, so I will not create again. So I already have a storage account, but this is I show how to create storage account. So for Azure function, you will need a storage account. I already created one storage account. Okay, so this is the storage account I created. The next option is the networking. This is for like security purposes. To enable public access, you will click on, or otherwise you can off this. And next is the monitoring. You if you want to add logging to troubleshooting, something like that, so you will use this monitoring feature as well. But it will cost you. For example, enable application inside. If you want the application inside, you will select yes, otherwise no. So currently I don't need inside for this demo, so I will select no because it will cost you. Mm. Next is the development. So you can create the CI/CD pipeline for your Azure function app. You can attach GitHub account, but you will select this option, continuous deploy. If you want, once this is enabled, you can select your organization, the repository you have in the GitHub account. So you can select your repository. Okay, so for example, this is the repository I created. So you can also create the branches there. So I will go without deployment. In the other demos, we will create CI/CD pipeline. For this demo, we will keep it simple. Next is the authentication. We will use the default options. And next, the take it's categorize the resource for you. So currently we don't need. This is optional. And next, you will review the application. So you will review subscription you are using, resource group, name of the function, secure default hosting. So this is the information, the option, the detail of the Azure function. If you make any mistake, you can go back to the specific tab and you can correct. So once you review and everything is fine, you will click on create button. So this is how you will create the Azure function app. So I will not uh, click on the create button because I already have one Azure function. You can see here Azure function. Azure function is created. You will see in the list here. Okay, so if you open this, you can check the detail of your Azure app. And please note this point that in one is Azure Function app, we can create multiple Azure function. So Azure function is different and Azure app is different. In one Azure app, we can create different applications, different type of Azure function. So once you open, you will see the overview of the Azure function, which resource group it is targeting, what is the status currently it's running, and location is Southern Asia, subscription and the subscription ID, and this is the domain name of this Azure function. You can also open this. You can see here this is up and running on this globally uniquely identifier. So or Azure app is running, and the operating system is Windows Server Plan, the service plan and runtime. Okay, so you can also check activity. We will cover this in upcoming sessions. You can deployment. This is for deployment. This is the functions, environment configuration. In setting them, you can see environment variable configuration authentication. We will cover this in upcoming lessons. Okay, so but is the basic the overview of the Azure function when you create. Okay, so and below in this section, in the function section, you will see all the function inside this Azure app. So this is for demo purposes. I created this just for practice. So this is the already created Azure function inside this Azure app. You can see the metrics. You can also see the properties of the Azure functions. This is the notification. So next, we will jump into the Visual Studio. You can write Azure function in VS Code and Visual Studio, but for this demo, we will use Visual Studio because it have rich in features. So like debugging and other, they provide a lot of things. So we will open the Visual Studio. So you will select create new app. Like we will create one health check Azure function and we will deploy it to the Azure app we created. So you can see here, you will search. I recently opened the Azure function, that's why it's coming in my list. If you don't see this Azure function, you will search here Azure function. You will select Azure function. Next, you will give a name to Azure function, like Azure function app uh, uh, 2 or something else according to your requirement. Function app and web 2, for example. You will select the location. You will go next. Uh, okay, so here is some important things like this is the worker, the function. We will select the .NET 8.0, and this is important thing like the function trigger. Each your function will have one trigger. So we will discuss this in detail. Like we have as you provide different type of trigger. If you say here as your function triggers. So the basic concept is that each function need a one trigger to start. Without trigger, we cannot start the Azure function. So we will definitely need one trigger to start the execution of the function. Where Azure function can run in parallel. And the other concept is that execution rank is varied by the hosting client we selected. So this is the first trigger, which is mostly used, is the HTTP trigger. It execute via HTTP request. It perfectly suitable for the APIs and webhooks. If you have to do something on an API or webhook, then you can use the HTTP trigger, like it support HTTP methods. The other one is the timer. If you want to do any schedule batch execution, so this will suit you. The timer, it supports encode depth model, so you can create your expression and it will run to a specific schedule. And next is the blob storage trigger. Whenever a blob is created or updated, so based on that you can trigger any Azure function. Um, Perfect for file processing and like logging, image logging, something like that, pre-war requirement. But it work for Azure block. Next, the queue storage trigger. If you have messages queue and based on that you want to trigger, you would use this queue. queue storage trigger, and the other one is the event grid trigger. It will work based on the Azure service event. It's used in the event grid architecture. The other type is the service bus trigger, complex workflow and inter application communication we can use. And the last one is the, if you want to work on the Cosmos data DB, so you can use this trigger, Cosmos DB trigger. So you can select, but for this demo, we'll select the HTTP. So you will select this. Next is the authorization level. Authorization level, if you want to add any authorization to your Azure function, you will select, you can select these options. But for now, we will go without authorization. So we will go for anonymous. So once you create, here you can see the function, the actual function that will deploy to the Azure function app. So there is also some app settings, and this is the program that is to this. So we will write some code here in this function app1. This is we are passing the Azure logger to log the information. So here we will write one health check function. For example, it will return action result, and we'll use the run method. It will run the Azure function, and there you can use the we will use the HTTP trigger, HTTP trigger, HTTP trigger, and we will give a subparameter like authorization level will be anonymous authorization level, and it will be a get with that, and the next variable we will pass the route. So we'll define the route for this function. So this will be the health, and for example, this is the route. Next, it will be HTTP request, HTTP request, and we'll get this. We will use this variable. So I will remove this auto-generated code. So run trigger anonymous. So, okay, so this is parameter is completed. Okay, so next we will do some logger. We will log some information. For example, log info, and write here some message. For example, and check function proceeding. Okay, so it's some logger information. Next, I will create a response object that will return the health of this function, and I will return that response. So function attribute this health check. This will be 3. Then check this is the function attribute we needed to make this as a function. So we can also we can note this public. Okay, so you can see here it's running, and this is the path, local path. If I open this in browser, you will see that this app is you can see that it's returned the status and the time. So it's running locally. In next, we will deploy this to Azure. For example, to publish this to Azure, we will click on right click and publish. Okay, so you will select the Azure. Next, you will select the Azure function app. Once you select, you will see the Azure app resource in your Azure function. You can see here, this is our Azure function app demo, which I created initially. So you will select this, and once you select, it will create the publishing profile. Publishing profile is created. Now you can see here, this is the publishing profile. And once I publish, for example, if you go to publish, it will publish the application in the Azure app. Publishing is succeeded, and we can now access this in Azure. So it's deployed to Azure. So you can see here, the function is now available in the Azure function app. So if you click on this, it will give you the detail of that function. This is the function. To get a function, you can copy and hit a check. So you can see here this is deployed to Azure and it's give you the same result. Okay, so I have a few questions for you, like which trigger fit for your use case. You will write this in the comment of this video on YouTube, and how you will organize your function, and what hosting plan meets your need. So this is the question for you. So see you in the next video. Thank you. Hello everyone, welcome back to Practical Serverless and Microservices with C Sharp. My name is Mohammed Abdullah and I am Microsoft Solution Architect. And I'm creating this course for .NET developer engineer who want to learn about serverless and microservices with C. In this video, we will understand microservices architecture. So what is microservices architecture? In microservices architecture is nothing but a software deployed on a computer network. Okay, and different microservices communicate via network protocol. And there is some constraint and rule that microservices must follow. We will see those constraint and rule later in this video. Sure, we have monolith application. Monolith application have large single system, one single code base, one deployment unit. They have like different problem. The first problem is everything is in one package, so one deployment unit. And the second thing is different technology in different department. And the third is they are difficult, they are hard to connect with other software. And the fourth problem is poor software communication, like they cannot talk with other system. So this is the main problem in the monolith application. So to fix this problem, service-oriented architecture is introduced. So they have some key feature, like they have a network of communicating processes, like each service talk together. So this is the key feature of the service-oriented solution. The second is modules are separated. So each module have a separate process, like they are packed in different pieces. And the third point is standard protocol communication. So they have some common language to that language they communicate. So and the fourth point is first step toward, this is the service oriented architecture is the first step towards microservice. So this is the first step. So you can see here this is a timeline, like in the first phase we have some SOAP protocol. This is the first implementation, which is the XML based. The second is the JSON based web APIs, lighter data format. And the second phase, the third phase, REST web APIs, like we already familiar with the ASP.NET web services. And this is the foundation for the microservice. This is the some timeline for the service oriented implementation. So here you can see service oriented architecture fix four problem. The first one, cross technology communication, like different tech work together, like Windows, Apache. So this is they fix this first key problem. And the second problem, which is fixed by the service oriented architecture, is independent versioning, like each module evolved separately. And public service offering, like they communicate with Google APIs, MS APIs, something they communicate with external app access. Okay, and the fourth problem is they have some protocol standards, like they talk with some protocol like HTTP, REST, and gRPC. They can communicate with text binary communication. So this is some problem which is fixed by the service-oriented architecture. And when this service-oriented architecture evolved, they face some issues, like the scaling issue is the major issue. So traffic increased, user increased dramatically. They need performance optimization, like speed become critical. So, and the third point is like hardware resourcing, resource allocation was the other key issue in the scaling. And the fourth one is the requirement, like in software we have to satisfy the new coming requirement in any feature, like to add or extend any feature. So this is the main scaling issue which is faced by the service oriented architecture. Okay, so you can see here as the system evolve, we have four new critical requirements. So the first requirement is system need to independent scaling. Each module scale separately. So this is the first requirement. Second, zero downtime, like continuous operation. Some company need zero downtime, like Facebook, Twitter need zero downtime. Other system like banking system. And the requirement number three is independent team independence, like different separate team per service. So this is the third new requirement. And the fourth requirement is like maintenance isolation. For example, if we fix one thing in one service, it do not affect other. So this is the four key new requirement. Okay, so to fix this, we have a microservices solution, like each module have separate service. Like we every service have their own each service will work like independently, and we can replicate. So service as many as a node. So this is the scalability. And they also offer orchestrator, like intelligent service management. We can create many copy of any node. And the fourth point they fix is the hardware dedicated resources. So this is the problem that Microsoft fix, microservices fix. And you can see here orchestrator role. We have orchestrator that can scale, like decide service copy count, scaling decision. They take the scaling decision, resource allocation, and they we can also multiply orchestrator possible or manual management. So this is the microservices solution. Next, when we work with microservices, we have some constraint to follow, some rule to follow. So the first constraint is we must follow the domain-driven boundaries. We must define domain-driven boundaries clearly, module boundaries by expert domain. Okay, so the second constraint is a replicable service. Every, for example, during scaling, if we need to scale up the service, it should be scalable. So this is the second constraint, and the third constraint is independent team, like different team work on different modules, different services. Fourth constraint is we must define the well-defined interfaces, and fifth point is standard. They have some standard communication protocol, and sixth constraint is interface only dependency. Like services depend only on the interfaces, not on the actual implementation. So it will decouple the system. It will not depend module A on module B. So this is the constraint we must follow on the in the microservice when we decide or design in microservices environment. So Eric Evan, according to the Eric Evan theory, each expert domain use typical language. If we go with the domain-driven design, each expert domain use typical language, and when language change, it detect the boundary, and when there is a common language, it show bounded context, and if there is any loose interaction, it show no common language. Okay, this is something about the domain-driven design, like applications split into when we design microservices, every module or some module have their own bounded context. In one bounded context, we have one module as well as we have multiple modules as well. So we will see this in detail. Okay, so you can see here, this is the second two level. There is one terminology which have the two level service decision. For example, if you have a e-commerce microservices, for example, then you have two approaches. The first one is we divide logically. We divide logical microservices, like we divide the team in three parts. Like for example, shopping cart team handle all the shopping related feature, and we also the business also divide into a payment team, like handle all the payment related feature, and the third is shipping team handle all the shipping related feature. And in the second level, like physical microservices, we divide deeper, like technicals. We split the teams more technical split, like shopping team split into product shopping and recommendation service, payment team split into payment processing history and refund service, and the shipping team split into like more deeper, like shipping, packaging, delivery. So the main purpose of this is to team independency and clear boundaries. We find clear boundaries. So this is main feature. Two levels, two level approach. We two level service or two level approach. So and you can see here, when we design microservices architecture, we have like team to manage team. We have like we use some tools like context map. In context map, we have usual team interaction. Like we usually define that shopping team will interact with the payment team, and inventory will interact with the shipping team. So it's like a neighborhood map. It show like a team relationship. So we use this in team management. This is one of the tool, and the second tool is the service catalog, or we also set a service directory, where we define the services owner of the service, cost, status, requirement, and we use tool like Swagger, Datadog, Postman for documentation. So this is why these tool matter, because it will prevent the confusion, it will reduce the meeting, it will track the cost, it will use for to plan better, and when any new team join, it will be easy for that new team. So this is some tool when we work with microservice, so we will manage a team through these tools. So when we design microservices, for example, each microservice have their own database, because if we don't have separate database, then for example, if service A and B share table T, for example, and service A modify the structure of the table, then these migration changes, the service B will also apply these changes. So this approach will break the independence principle of the module. So the rule is only same service instance can share database. Okay, so this is the some principle you will follow during designing microservice. There is some challenges when you work with microservices, like you will face data duplication challenge. The problem is in microservices, for example, service A and B, service B need some data from service A. So we must duplicate the data inside service B. Okay, so this is some inevitable change. We must replicate the data, but we will follow some rule, like we will minimize data duplication. And other point is we will duplicate the data in few microservices. We will try to there will be a few microservices that will duplicate the data, and only duplicate those data which is needed for that microservice. Okay, so in this slide we will discuss the communication between the different microservices. Like for example, if we have one microservice that need to call the service B, and service B call the C, so it create the sequential dependency, and it will add up the response time. Like the service remain block, it will wait, and we invest the computation time, and the response time will be higher. So this is about the synchronous communication. For example, if we call one service and the other service call the third service, so it will create the sequential dependency. So to the solution for this problem is synchronous data sharing. Like this is the proactive approach where service send data when data change, and it's a pre-processed data, like pre-processed data sent to the potential caller, and there is no wait time for that request, and data is available when it's needed. And this is the synchronous communication between the microservices. Like the other one is the request response, which is the traditional one. And like a client send a request, server process, and it respond. This is something like synchronous, like wait is involved in this case. And in this case, response time is up. And about the message-based communication, like it's a data-driven communications, synchronous messages, and it's acknowledge versus response. In the message base we have acknowledged, but in the traditional one we have response, we wait for the response. And some benefit of the synchronous communication, like we completely avoid the wait time. The message sent in a queue, like we can use the rabbit mq and the mass transient if we have in memory calls. If we have like the microservices deployed in different machines, so we can use the like rabbit mq. um, yeah, acknowledge mark completion. We have retry policy. For example, if any message fail, we have retry mechanism, and there is a timeout handling, and error recovery mechanism is also available in this case. So this is all about the section number 2. In the next video we will discuss microservices type and some patterns related to the microservices. Hello everyone, welcome back to Practical Serverless and Microservices with C Sharp. My name is Muhammad Abdullah, and I created this course for .NET developer and engineer who want to learn about serverless and microservices in C Sharp. So this is section number 3, and if you missed the section 1 and 2, please check out the playlist. So I will share the link in description, so please check the link and first watch the section 1 and 2. So in this section we will cover microservices types and some different patterns. So you can see here we have some front-end microservices and worker microservices. So there is a difference between these two microservices. So the front-end microservice face the client like the user. It's the user-facing microservices that perform the client request and response, and it can also handle multiple parallel requests from different user as well. And thread or request pattern, it follow thread or pattern request. So you can see here in the diagram we have different microservices. Some of them is front-end microservice, like first query microservice, and at the bottom we can see update microservices. This is the front-end microservices, like it facilitate the user or the client. And the next is the worker. You can see here in the diagram we have in the middle we have worker microservices that only deal the inner communication, like no direct user interaction, only process the data. It work in the assembly line operation, and it also work on a queue-based processing. It perform queue-based processing. So this is two types. One is the front end, the other one is the so here is the example of car sharing application. So in the whole course we will focus on this car sharing application. We will create services for it. In this example you can see here we have like 6 microservices, routing, location. At the top we have like routing, allocation, best matches, and at the bottom we have car sharing that fulfill the request, car seeking, and route choosing. And in the middle we have the planner, which is the worker microservices. The top three and the bottom three are the other type of front end microservice, and the route planner is the worker microservice. So this is the example of the front end and worker microservice. So next, you can see here a car sharing application. When we do analysis, we find two domain. The first domain represent car sharer language, which represents 6 microservices, and the second domain is the routing language, like the meter route planner. So this is the two domain we will cover in this course. And if we check the architecture layout, the top microservices are the query. It only give data to the user, and the top microservices they are update microservice, and the worker microservices in the middle. You can say the gray shaded. So this is the worker microservice. Mostly query and update microservices are the front end microservices. So this is some indication. So you can see here, this is the car holding journey. Car holding journey, it handle all the crude operation for the car owner and manage trip creation and availability. And it also integrate with route planner. If you check in the diagram, car holder, it also interact with the route, location, and route planner. And route choosing update microservice, you can see here, car holding accept car seeker, select route matching, resource destination, remove incompatible option after match. So this is some information about the microservices we will cover in the course. We will actually practically do this all microservices. Okay, so the car seeker request, if you check the car seeker request, it will handle all the passenger request. It will also do the CRUD operation like the car holder, and it will also submit the request after date selection. They will select the date, and it will send the request. So this is something about the car holders and the. Okay, so in this slide we will check the complexity reality check, like some truth about the microservices, like if in microservices we have like different services on different machine, so the testing become complex. So this is truth about microservices. And the maintainability is time consuming, and complex data driven communication pattern. We will follow complex data driven communication pattern, and it will also increase the cost. So this is some truth about the microservices. So while choosing the microservices, you will also keep this in mind. Okay, so here many people ask question like when to adopt microservices. So here is the some use cases. So if your team is more than five, you can go with the microservices. And if your application have high traffic and time consuming modules are there in the system, so you can go with microservices. And if you need a module level optimization, so you can also choose the microservices. And in microservices we must split the tree, because it will define clear boundaries, and it will avoid ambiguities. So when not to adopt the microservices, if your application is low traffic, and you have small team, and the requirement is straightforward, so you can not adopt microservices. So next, we will cover some patterns in microservices, like why we use patterns. So in microservices, we face different problem. So developer and programmer create solution for that particular problems. So that solution became patterns. So whenever we face the same problem in our microservice, so we can use the existing pattern instead of creating our own pattern, because the already created pattern is tested and it work for other users as well. So uh, we will cover some microservices pattern, mostly concerned with the resilient task execution, which is the one of the microservices pattern. Okay, so what is resilient task execution? So in microservices can be moved between machines for load balancing. Okay, so load balancing like distribute traffic between nodes. So so also the microservices can be restarted to recover from memory leakage and performance issues. And some microservices can also miss some messages during any operation, and it also fail due to software bug or hardware bug. So to deal with this, we have some strategy like failure detection strategy. So in this case, we have two methods. One is unexpected exception, and the second one is the timeout exception. Okay, so we will see that how we can cover this failure. So we have some reliability patterns. So they have three major standard patterns. The first one is the exponential retry, and the other one is the circuit breaker and bulk ahead isolation. So we will check this one by one. So the first is the exponential retry. So what is the purpose? To overcome temporary failure. Okay, so like when service restart, during that pattern, we implement the retry, and the retry increase exponential number of retry. And when the maximum number reach, we throw exception. So we can use the exponential retry pattern in to get reliability in the microservices. The second one is the circuit breaker. Okay, like when exponential try reach maximum, in that scenario, we use the circuit breaker. We can block access to resource for fixed amount of time, and return immediate exception, allow time for human intervention or manual fixes. And it also circuit breaker also prevent cascading failure. And the third one is bulk ahead isolation, and it prevent failure and cognition propagation. So here is one point. What is cognition propagation? So cognition propagation happen when one service become slow or overloaded. So it start consuming all shared resources of other microservices, like thread CPU and DB connection. Other services that share those resources also slow down. So this is called cognition propagation. So bulk ahead isolation prevent cognition propagation. Okay, and the replica use same database. This example, um, and one replica open too many connection cognition database for all the replica. And what is the solution for this is a partition connection. Like we will define maximum number of replica per service. So this is the solution for it. So you can see here we have some strategies, we can limit active requests, like only 5 database requests at a time per service instance we allow. This is one strategy. Second one, extra request, keep the extra request in the line. And the third one is if the line is too big, the queue of the message, the request is too long, stop extracting more requests. So this is the third strategy. And the four, when return error is instead of crashing. So if there is any bug or crash scenario in our microservice, so instead of crashing, return the error. So this is some strategy to bulk ahead implementation. Okay, so next is the communication pattern. Like we have output input messages queue, which is needed for reliability, and publisher subscriber. We can get the loosely coupling, and the other one is the event-based messaging, which is we will cover this in coming slides. So when we implement the synchronous communication, we face some few challenges. Like keep messages copy until acknowledgement. So we will keep until the consumer of the message is does not implement or accept receive that message. We can enable retry operation, handle communication failure. And the second is the message duplication. In many scenario, this is a challenge in the synchronous communication, like message duplication. And the other one is the message order. Like message can uh, arrive out of order, and wrong order can cause data consistency. So this is a few things, few challenges we will fix in asynchronous communication. So what is output message queue solution? What is the solution for output message queue solution? So here you can see in the diagram, queues all output messages. We will keep all the messages in a queue, and when any consumer acknowledge the message, just remove the message from the queue. And if any message fail or time out occur, so just requeue the message, and include attempt number of exponential retry. We can add the retry mechanism, and store minimum retry time per message. So we can also define minimum retry time for each message. Okay, so this is output message queue. The other one is the input message queue solution. Okay, so here you can see recognize and discard duplicates. So in this pattern, in this communication pattern, we will avoid to duplicate. We will recognize and discard the duplicate messages, and we will reconstruct the correct message order. And what is the processing rule? Read message only after filling sequence call. You can see here in the diagram. And what will be the result? Order. We will keep the messages in order, and the duplicate free message processing. So this is what we can get from the input messages queue. It will remove the duplication, it will give order. Okay, in event-based communication, we face some challenges like want to add a statistic. If you want to add a new microservices like that will give you statistics to the car sharing example I shared in the previous slide. So what will be the problem? These statistic microservices need like some data from the existing microservices. So what you will do? You will modify the source microservices. So if you do this, you will violate the modification should not propagate principle. So what is the solution for this problem? The solution for this problem is the publisher subscriber pattern, which is the another communication pattern. Okay, you can see here in the diagram, sender send message to the publisher endpoint. There is no direct communication reception, and interested microservices like recipient one to subscribe to that publisher endpoint, and publisher automatically forward message to all the subscriber. And new microservices, what will the statistic microservice will do? It will just subscribe to that pattern to receive the messages. So in this pattern, we can get the microservices independency maintained. So we can get the each module will be dependent. Okay, so for this we can to also use the message broker, like handled by application called message broker. We can use the message broker like in market we have RabbitMQ and Azure Service Bus, which offer a publishing message, and it will deliver to all the subscriber. So this is a message broker, and here is the summary. Like to get the resilience in the microservice, we will follow some patterns like exponential retry. It will use for temporary faults, circle bracket, long-term failure, and bulk ahead isolation failure containment, and some other communication patterns like output input messages queues. We can get reliability. Publisher subscriber, we can get the loosely coupling, and the event based messages. So this is all about the. Okay, in the next section we will cover the Docker and Onion architecture. And if you are new to this channel, please subscribe, and if you have any questions, so you can ask in the comment. Thanks for watching. Hello everyone, welcome back to Practical Serverless and Microservices with C#. My name is Mohammed, and I'm Microsoft Azure Solution Architect. And for this course, this is my agenda. So first, we will understand the how serverless application work. Then we will look the microservices, then on architecture, then how to work with Docker. We will understand different type of Azure function, their types like trigger, background functions, IoT function, and microservices, how to organize microservices with Kubernetes. Then we will see the containerization in microservices with help of Kubernetes and Azure Container App. Then we will check the security observability inside serverless microservices. And in the whole this course, we will consider one car sharing app. So we will see this in action. And lastly, we will understand how .NET Aspire work. So if you missed the other session like 1 to 3, so please check out the first, second, and third, then continue the for this session. And yeah, I will share the link of the playlist in the description of this video. So in this session number 4, we will understand the onion architecture. First, we will see some of the theory. After that, I will show you this in practice. Then I create one template, and I will show each part in the template. And I will also share the template link in the video description. So what is onion architecture? So there is one principle like the onion architecture software design. First of all, this is a software design pattern that organize the code in layers. So onion architecture have different layers, but the key principle is the dependency direction. So like the outer layer can reference inner layer, but the inner layer does not have reference to the outer layer. So this is the key principle of the onion architecture. So this is the basic diagram. We have the first layer, the infrastructure layer. Then in the middle, we have application specific code. So infrastructure, we have databases, file, cloud services. So this is the basic version of the onion architecture. So the core concept, you will think like a onion. The innermost layer contain your core business logic, but what your application actually do, it's in the inner layer. While the outer layer handle technical concern like database, web APIs, web interfaces, and the external system. So this is the core concept of the onion architecture. So in onion architecture, we have, as we mentioned in the slide, we have some like different type of layers. So outermost layer is called the infrastructure layer. It contains all the technical drivers like database connections, web frameworks, UI components, and it handle the dependency injection and reference all the inner layer, but never referenced by them. So this is the outermost. We will see this in diagram as well as in code as well. So second, we have if we go check this is the complete onion architecture. As you said, as I mentioned that in the outermost layer we have infrastructure. Infrastructure have databases, files, cloud services, and web APIs. So this is the first layer, the infrastructure layer, handle dependency injection, reference all the inner layers, but never referenced by other. So second, we have application layer. Define what operation your application can perform. So in this layer, we have all the use cases, all the like command handler queries inside this layer. Like it contains use cases, application specific workflows, and it have only referenced by the domain layer. So this is the second layer. We have application layer, and this is the heart of the onion architecture, like the domain layer, which is also called the core layer. It contains all the business entities and rule, and it's the heart of the application. Like what application fundamentally do, it's inside the domain layer, and it has no dependency on other. So we will see this in action. It has no reference by other project. And domain layer sometimes like split into model like entities and domain services. We will see this in action. Like we will cover this course with respect to domain-driven design. So in domain-driven design, we have entities, aggregate, root aggregate. We will see this in practice. So this is a complete diagram of the onion architecture. First, we have the infrastructure, and then we have application services, and then we have a domain layer. So infrastructure have database, web APIs, and other UI component, and application services have all the use cases, what the application can actually perform, and the heart of the application domain layer, all the business rules and models is inside in the domain layer. So this is the complete onion architecture. Okay, as you can see that this is the onion architecture template. So as you can see here, we have basically four layer. The first one, we will go one by one. So first we'll discuss the infrastructure layers. So infrastructure layer, we have a DB driver. So there is one C# class library that contain the database related things, and we can also call the web API layer as an infrastructure layer. So these two layer, web API and DB driver, is the part of the infrastructure. The DB driver handle the DB connection. You can see here, this is DB context. It has all the required model and all the migration related things. And if we go to the repository, it has all the repository implementation. Like in this template, I'm considering the car booking application. So it has booking repository, car repository, and and user repositories. So also we have extension to connect this model to others. So we have this extension. We will call this in like a program.c, the main dependency injection. So this is the infrastructure layer. And second, if I go back to the, you can see here. Um, the first layer infrastructure, then we have application layer. So if you go back to the code, you can say here application layer. This is the application layer. And first I will also show you the references. So the key principle of the onion architecture. This is the infrastructure layer, and it has only reference of the domain layer, so nothing else. Command handlers, like it will create booking, it will create car, create user. So this is like the command handlers for the use cases. You can see if I open, so this will create a booking for us. So this is one of the use case. And in this folder, the command folder, we created the command like if we are going to create a booking, so this will be the command. This is like a request. Okay, first we will pass the user ID, car ID, start time, and end time. So this is like the command for this command handler. Um, you can see here I'm passing it the iRequest handler. So this is the command we created in the command folder. So next we have events. Some like inside microservices or domain-driven design entity. So when any entity change, and when any change happen in entity, so it will create some event. So when booking happens, this event will be will be raised. So we will see this in like a detail. In the domain-driven design, we have extension like a data dependency injection handler, and this is a service collection to connect with other part of the application. And then we have queries. So we have in the CQRS we have some command and queries. So for this we get all the available cards. We have this query get user booking. So we define all the queries here. So this is my main point is to show you the application layer. It has all the use cases. The domain layer. The domain layer have like all the domain entities, all the business logic. So this is model, booking model, for example. This is the booking model. Username car, and this is the all information needed for the car. This is the user. So we have all the core model inside this domain layer. So let's come back to the slides. Okay, so I practically show you how the domain get look like. Like first we have the infrastructure, then we have application, then we have the domain layer. So the dependency is going inward towards the domain layer. The domain layer will be independent. It will not contain any reference. The application service will have reference only to the domain layer, and the infrastructure layer have only reference the application layer, not the domain layer. So this is the dependency principle for the onion architecture. Now, next we will cover the domain layer of the onion architecture. So core concept is contain domain entities like classes with behavior encoded with public methods, and entity can only be defined through the method presenting actual domain operation. You can think like as a domain-driven design. We will focus mainly on the domain-driven design. So also use a unambiguous language, and the business team will follow the same language. So this it's called the unambiguous language. Okay, so then we have the domain layer. Domain entities. We have state. State can only be changed through the method that encoded actual domain operation. And we have aggregate. Aggregate must be completely covered from the persistence code. And we have like each domain layer have one repository interface as well. And in the domain layer, we have like one is called the domain entity, and we other have the core EF core, yeah, entity framework core entity. Domain entities have method enforce business rule, and tree of nested object like aggregate. Aggregate is the group of related object. It's called the aggregate in a domain-driven design. And uh, EF core entity just have a property value pair with no methods, and it have only save data inside the database. So there is some difference between these two. Okay, so please understand this. Domain entity have method enforce business rule, and it also have the aggregate like a group of related entities. And but the entity framework entities just property value pair. And when we have aggregate, what is aggregate? Complex tree of object related order. For example, if we have order, and the other object is purchase order. One is called purchase order, and the other one is purchase order item. So this is the example of the aggregate. So we will also check the aggregate root as well. For example, if we have purchase order, and one is purchase order item. So order item cannot exist without the purchase item. So here the aggregate root is purchase order. And child object cannot exist independently, like purchase order item cannot exist without purchase item. So manipulate it as a single unit. So we can treat this as a single unit, also called it aggregate. So here is the example of the aggregate. We have purchase order where we have purchase order items. Okay, and the only thing that can change or manipulate the purchase order item is the purchase order. We cannot access purchase order item outside the purchase order. So this is the rule of the aggregate in domain-driven design. So you can see here in this purchase order, we can add, we can remove item to the purchase order item list. So this is the rule of the aggregate inside domain-driven design. Then there is one another concept inside domain-driven design is the value object. It object with no identity. So in identity, in domain identities, we have one unique identifier. So each record can be identified uniquely. But in case of value object, we have no ID. There is no identity inside this object. Like for example, if we have address, in address we have phase number, street number, house number. So these three create the value object related to the address. Same for the money as well. And it's mutable. Once it's created, cannot be changed. And implemented as C# also provide the record, so we can implement this as a record inside when we do actual coding. And there is no repository needed for a repository interface needed for value object. So here is the example of the value object in domain-driven design. For example, if we have address like country, town, street, so combined we create one record which is called the value object. So next we'll cover the repository pattern. Since aggregate and value object differ from ORM entity, like ORM actually save the data inside the database, but aggregate and value objects are different. We checked in the previous slides. When using ORM to interact with database, you must translate ORM entity into aggregate and value object and vice versa. Each time exchange data with ORM. To the ORM, we exchange data from the ORM entity to the aggregate and value object, and aggregate and value object to the ORM. So in this case, the domain layer interact with actual ORM implementation to the interfaces. So in this case, we need the repository pattern. So this is the core concept why we need the repository pattern in the domain-driven design. So this is the reason. And there is one rule, each aggregate root. I already said that aggregate root, main entity in a group of related entity. Like in aggregate, we have related entities, and there is one key entity which is called the aggregate root. All the child entity aggregate depend on the aggregate root. Should have its own repository interface. Aggregate root, one repository interface. This is the rule, and the repository work with the whole aggregate, not with the individual entity. So this is another rule. This keep your code clean. What is the purpose? It keep the code clean, modular, and aligned with DDD, domain-driven design. So we will follow the domain-driven design principle. So that's why we need this repository pattern. We must follow this repository pattern rule. Example of this repository pattern is purchase order. For example, in previous slide, we see this is a purchase order. This is one aggregate. And what is the root aggregate? Purchase order is the root aggregate. And what is the child entity? Purchase order item is the child entity. So this aggregate, it will need one repository. And here is the rule. This is the example of the repository. Okay. And we have new get async, delete async, deleted async with the purchase order, and get delete. So this is all the functionality it will provide. So it will need the interface. So next we have a domain services layer. In complex application, it's best practice to split the domain layer into model layer and domain service layer. Okay. So domain layer contain only aggregate like entities and value object. Entity have unique identity and value object without key. So this is key difference. And the domain service layer. What is the purpose of domain service layer? Contain repository interface and domain operation that does not belong inside the aggregate. So contain repository interfaces and the domain operation that does not belong inside aggregate. So this is each like model have domain layer have domain service layer as well. So domain service layer have the repository work only with aggregate like order customer, and but sometimes you do not want to in the whole aggregate. You just need a read model like get data from any database. The domain service you want to show a dashboard. For example, if you want to show dashboard with customer name, order total order, and last order date. So this is the requirement. So this will not come from the single aggregate, but it will come from like customer and order. So here we will use the domain service that will interact with different domain or different entities like customer and order. Now we will go deeper into the application service. It's a layer above the domain layer. So you can see here, this is our application layer. So it's have only one reference domain layer. So it's the layer above the domain layer. So the second layer, application layer. We will discuss this in detail. It does contain domain rule itself. For example, order cannot be less than zero. Something like when we add item to the cart, or when we place order must be greater. This is one of the simple business rule domain rules, and not live in the aggregate and domain service. But it accept command, it accept what is the accept command and query. The accept command and query. You can see here it have the command and the queries. call the right repository or query service. Publish domain event is something important. We can see here these are events. When booking are created, we will raise this event. So application service also raise the domain events as well. Okay, we have a command operation, query operation, command modify aggregate to repository. Aggregate to repository can raise domain event as well, like place order event. And query use query service, it return details tuple, and, no domain events, just return data. So this is about the application layer. And when you go to the query, it does not have the event, no domain events, just return the data. But this, like we have create event handler command. When booking is created, this event will be generated. You can see here when we create the booking. So when we create the booking at the last point, publish domain event. So this is called publishing domain event. Command raise the domain events. So this is I explained this in code. Application service operation. Operation in the application service layer are split into two types, like queries command. Already discussed. Command execution can trigger events. Also, application service must also handle domain events. Already explained. And we have queries. This is the some deeper look of the queries. A query object represents one or several similar queries. Usually have one or several method that take input and return queries. Query result. If we go to the query, for example, get available car query. So it will get this query. We are only passing the location. This is the query, and this is the query handler. Most query method call a single repository method implementing the needed query to some may execute several repositories. So a query can also get data from single repository. It also can get data from multiple repositories as well. Next, we have query testing. During system testing, actual query implementation are placed by fake implementation. So each query has associated interface coupled with the actual implementation in the dependency engine. This enables the UI to require only the interface to infrastructure. Allow testing with fake implementation. If we don't use the interfaces here, so the system will be unable to test. So to test that, we must, like you can see here, this query is inherit from the I request handler. If we don't do this, like inherit from the any I request handler, the system cannot be testable. So to make the system testable is most important thing. So we must follow this testing principle. So like this is the example, we have one query that contain it will return the basic information video, and it will take the start. And you can see here we are inheriting this purchase order by started from the I purchase order by start get query. So this is important thing, and I purchase order by started query is inheriting from the I query interface. So iQuery interface is necessary for to make this system testable. Next, we have command. We will see the command in detail. Command work differently because each command represent a single application operation for better code readability. Like command, we follow the single repository principle. Like each command will have only single operation. So each a unit of work, like a unit of what is a unit of work in DDD or CQR, plus CQRS. We are following domain-driven design and CQRS. Like in DDD and CQRS, each command load aggregate via repository, call method on them to apply changes, command apply changes, and then we have save changes. So first we load, then call the method to apply the changes, then we have another save changes in database. But in reality, you may touch multiple aggregate in a single command. Uh, you want them all to save or roll back together. Like for the transaction, if we deal with multiple command, so to make this atomic transaction, this we will use the a unit of work. The job of the unit of work to make all the repository operation to make it in a single transaction. If I go back to the here to the code, you can see here I have a unit of work. So it will make the atomic transaction. To make the transaction atomic, we use the I unit of work. We save entities. We have start async, commit async, and rollback async. So example have unit of work example. Save, start async, commit async, and rollback. So unit of work breakdown. We have save entity async, save all the update in a single transaction. Return true if storage actually change, otherwise false. And start we use to start the transaction, commit and rollback, respectively commit or rollback and open transaction. So this is needed to make the data consistent. Okay, so unit of work, transaction control method are useful for this is the save, start, commit, and rollback. So this method transaction control method are useful for in closing, get operation, and final save entity async save in the same transaction. So example of this is we start the transaction, we get all the flight async. If like there is no seat, we roll back. If the seat is less than zero, we roll back the system. Otherwise, we commit. Okay, next is the domain events. For example, let's go back to the code. Uh, Let's go back to the code. You can see here when booking is created, this is raised. The booking create event is raised. So this is called domain event. This is called domain event. Raised inside the same microservice. When something happened to aggregate, when something changed in the aggregate, the command raise the domain event. For example, order placed event. In our example, booking created event. When a new record is created, handle inside the same microservices. So it will be inside the microservices boundary, and it follow the publisher subscriber pattern. So for example, this is the publisher, and where is the subscriber? It will be inside the handler. So this is the actual event handler. So whenever anyone subscribe, it will subscribe to this one, and it will be notified to the event notification. Okay, there is two things, like one is the domain and the other one the integration event. So anything happen inside the microservice, it is called domain event. But if one microservice can communicate with other microservice, then we use the integration event, REST to communicate across the microservices. Example, order place integration event, send to a payment microservices or notification microservice. So here two microservices are communicating to the integration event. So this is two type, like one is domain and the other one is the integration event. So why we use the event like inside microservices boundary? So why this important? Aggregate arrays event about important state change. Instead of writing side effect inside aggregate, we capture the event. We capture the event. This event can collect it, and then the command handler publish them before calling unit of work. These ensure that events are only published if the transaction succeeded. So if we go to the code here, you can see here we publish the event after making changes to the card repository. Then we raise the event. So this ensures the event are only published if the transaction succeeded. Otherwise, we will not. So we will also take help of the unit of work, save changes async as well. That's why we define events inside the microservices boundaries. So this is the structure of the event. We have interface, and then we have a handler. If I go back to this is the publishing event code, and go inside. This is the domain event, and this is the definition of the event. And we are inheriting from the iNotification handler. So this is the example iNotification event, and associated each event with all its handler. So here is the example how to associate event with all its handler. So we have event triggers, and inside that we have one structure, then we have one trigger. We will learn how domain object work with database, because the business logic of the domain should not know about the databases, because if they do, they will violate the user. It will use the infrastructure layer, so this is not recommended. So database store data in table and rows, and the business object like aggregate work differently than the database table. Like we cannot pass domain object directly to the entity framework. Entity framework model is different than the aggregates or a business domain, and EF core does not track or domain objects. So this is one of the problems. So how we will fix this problem? So there is one solution called a state object pattern. State object pattern. So the core idea of the state object pattern is that it separates the state from the behavior. So state mean like data, like object has some data, and the behavior mean the logic. So with the help of state object pattern, we separate the state and behavior. So how we'll do this, we will see in the next slides. So first of all, for example, first step, we create the state interface where we define all the properties like creation date, delivery time, and list of item. For example, if we use the purchase order state. So this is the first step. The second step will be business object use this. So we will pass this state interface inside the constructor. We will use the aggregate constructor, and we will pass that state with the help of constructor. And then we will save this state inside private variable, a private state variable. As you can see in this example, we have one private variable, I purchased order state, and I am passing the state inside the constructor, and we are saving the state inside the private state variable. So this is the second step. And the third time step, you will modify the entity, like database entity. You will inherit it from the interface purchase state. So as you can see here, in the first step, we created the state interface, and we are inheriting the database entity from that state interface. So this is the last step. So how I will show you this in the code. Like if I go to the code, so you can see here, I modified the code to fulfill the requirement of the state pattern. Okay, so you can see here now this is the aggregate, and I created one state interface called iCar state. You can say if I go to this, you can see here, this is all the properties needed for this aggregate. And this is the first step. And second, the aggregate is we are passing this state interface using this aggregate constructor, and we are saving the state inside this private variable. So this is the example of the state object pattern. And you can see here we have in this class we have behaviors, and we have behaviors, and the state is located in this state interface. And the second part, this is the database model. We are inheriting this from the istate call. So this is the last step. So you will follow this pattern to make this like state object, to follow the state object pattern. So that's in this way we can communicate with database. And so this is the example of the state object pattern. So here is the so this is the life cycle of the aggregate life cycle. So first, for example, we need some customer data. So we'll use the repository interface. It will get all the data from the repository using the DB driver, and the DB driver will contact with the ORM. ORM will map the data, and it will get the data from the database. So this is the first flow. It will get the data. So you can see here from the right side, the database will provide you the tuple, and then the ORM will start tracking that entity. ORM will start tracking the entity, and the constructor aggregate will accept the state of the uh, state of the entity by using the aggregate constructor, and it will create new aggregate. You can see here in the dashed line, the aggregate is communicated accepting the state through the aggregate constructor. So once aggregate receive the state, then we will make changes to the data. Then unit of work in the last flow, you can see here from the left to right, we have unit of work. After making changes, we will call the save entities, and implementation of unit of work will pass that changes to the ORM engine. Basically, the ORM engine will follow the tracking. So the magic here is the tracking. So you can see here the dashed arrows. It will track all the changes, and it will update the data inside our database. So this is how the state object pattern work. Okay, so this is the last topic. So I hope you will find this helpful. If you have any question, you can ask. And if you are new to this channel, please subscribe and like this. Hello everyone, welcome back to Practical Serverless and Microservices with C#. My name is Muhammad Abdullah, and I am Microsoft Certified Azure Solution Architect. For this course, our agenda is to understand the serverless application, how serverless application work, how to deploy serverless application. We'll understand the microservices on onion architecture, different type of onion architecture like domain layer, application layer, and infrastructure layer. Then we will learn Docker, and then Azure function. There are different triggers, background function, IoT function, microservices in detail, and we will see microservice organization with Kubernetes, how to use Kubernetes with microservices, and then we will learn practically container and Kubernetes and Azure Container App, and how to apply security observability for serverless and microservices application. And for this course, we will see the car sharing application microservices practically, and lastly we will see microservices with .NET Aspire. So this is our agenda. If you missed the previous lectures, please check out, and you can continue. Session number 5 is related to Docker, so we will learn about Docker. So microservices need to be independent of their host environment to enable easy load balancing and to use the hardware utilization. So we are facing one challenge, like if we are working with legacy application with newer modules, they use the different development stack that create dependency on the environment. Each stack has own requisite. So this is our challenge. To fix this challenge, the older solution is to deploy each microservices on the separate virtual machine. So this is the old solution, but here is one problem with this solution, like virtual machine are slow to start and stop. So this is the problem with my virtual machine, because they have their own copy of the operating system, which is insufficient for microservices that need to be quick, like microservices need to be quickly start. So this is the one problem with virtual machine. So we can fix with this problem with the container solution. Like container is lightweight and efficient form of the virtualization. So in this video we'll see the container. So the container solution, how they work, like virtual machine that utilize the entire machine, including the operating system. Container utilized at the file level, and they sit on the top of the operating system kernel, and they use the host operating system like kernel DLL driver, but use its native feature to isolate processes and resources. This create an isolated environment for the application they run. So this is the how the container work. Like we will see this in the diagram. Like we are comparing Docker container and virtual machine, and you can see here virtual machine have infrastructure layer, then host operating system, then the virtualization tool hypervisor, and it have like three virtual machine 1, 2, 3, and they each virtual machine have their own guest operating system. But in case of Docker, they are using the host environment, like host operating system, and they use the Docker engine, and they create a container to run different applications. So this is the main difference between container and the virtual machine. So a container have what is container, like the running instance of application is called container. They are created from the images. So first we have images, then from images we create containers, multiple instances of container. And what is images? Already read-only template that contain all the necessary code, instruction, library, dependencies to run the application. The same image can be used to create multiple identical container. We can create multiple container from single image. And what is image directory? Where images are stored and managed. Like you can think like a Docker hub. We can store images. In Docker Hub, we can also use ACR, Azure Container Registry. So this is a type of repositories where we can save the images. And this is the naming, image naming and tagging. For example, first of all, we have, this is the example, ncr.microsoft.com. So this is the part of the domain registry, and .NET is the namespace, and ASP.NET is the repository name, and the 9.0 is the tag number. So this is the URL of the image. Whenever you need any image from any repository, you will just place this URL, you will get this URL, and you can use that image. So this is the URL of the image. And now we will discuss the container and image lifecycle. Like process, any runtime that need to create container, download the required image from our registry. So for example, if you need a .NET runtime, so you will use you will get this from registry, and you can use it. Some images required credential as well. Like there is two type of, one is public, one is the private one. Private one need the credential as well. Image to container. Once the image is downloaded, when you download the image, the runtime use it to create one or more containers. So then we can create container as many as we want. So here you can see here the instruction Docker file is nothing but instruction. Then we create image from that, and we save ACR or a Docker hub, so we can use that, and then we can pull and we can use, and we can create containers. So here we will see the Docker. What is Docker? Like a de facto standard for working with containers. So we have Docker file. Any runtime that need to create container, download the required image from the registry. It may need credentials to access the registry. Building images. Docker images are generated by applying change. Okay, so now we'll discuss the form instruction. Like when you create a Docker file, they have the form instruction. Like Docker file usually start from a form. It specifies the base image to modify. For example, form ncr.microsoft.com/.net/asp.net and 9.0. So this is the form instruction. You will see this when we do a practical Docker file creation, and this set the build stage or the starting environment. So this is the, like your computer pull the image, and it's built, and they, after building they run the container, and you can see the application. So this is building. We will see this in practice as well. We will build the image. And registry URL, the full URL specify the registry domain. We already discussed how the URL look like. They have the registry domain, namespace, repository, and the tag. We already discussed. This is the example. You can use any type of registry, like Docker Hub registry and Azure container registry. So this is up to you where you can store the image. And we have the images in hierarchy, like the images and container in the hierarchy. First, like image 1, 2, and you can n number of images, and each image have n number of containers. So this is some of the hierarchy of the images and container. Okay, so key Docker file instruction. So when we see the Docker file, we have working directory instruction. Like we discussed the form, now we are discussing the working directory. So working directory define the current working directory inside the image file system. If the direct does not exist, it's create. So below is the command instruction, the full instruction. So yeah, so next is the copy instruction. Copy file or folder from your computer into image file system. Can copy a single file, a whole folder, and multiple file as well. Here is the command instruction. So we will see this all the command in our Docker file. And next is the run, execute a shell command inside the image. For example, run .NET restore. So this is the type of the run instruction. Next is the CMD and entry point. Specify the command in argument to be executed when a container is run for the image. So below is the CMD and entry point instruction. And next is the expose. Declare the network port that container support. It acts as a documentation. It does not block traffic to other ports, but signal which port are intended for use. So this is for port. We can use the expose. And if next we'll discuss the stages Docker file have sometime multi-stage build as well. So what is the concept behind this multi-stage build? A Docker file can build intermediary image to create the final smaller image. For example, create an image that contains the entire .NET SDK using form instruction. This is the build stage, for example. And then use run to compile your entire .NET solution, and create a separate final image using a different form instruction, like just the .NET runtime. So once your application is built, then you will need the runtime to run the application. So this is multi-stage build. We'll see this as well. And use copy from build to copy only the compiled binary from the build image into the final stage. So what is the benefit of this? The final image is much smaller in size because it does not include unnecessary build tool or source code, which is more secure and efficient for production level. So if you want to do a production level setup, so you can use the multiple stage build is highly recommended. So for example, I will go back to my Visual Studio. So you can see here, this is a multi-build stage. This is the base. It's create the base. So this is stage number 1, the base stage, and this is the build stage. This is the build stage, and this is the publish, and this is the final stage. So this is like multi-stage Docker file. So the only purpose is to get the smaller image. So I will go back to the slides. So okay, next is getting the Docker file. If you are new to Docker file, you can install the Docker file on your Mac machine and Windows machine. I already have downloaded. For example, what Docker file are required for using Docker on your personal computer. It includes like a Docker runtime to create and run the container from images, a Docker client to build images. We can run, and we can also store the images in local registry as well. And this course, assume you are using the Windows machine with WSL. Windows subscribe for Linux, install and configure for the Linux container. So I already installed WSL for Linux. So I will go show you. For example, if I go to this is the Docker desktop application. You can see here where you can find all the running containers. So this is the one container which is currently running. When you click, you can go to the log. You can see the application is currently running. You can inspect, and this is bind mods, execute files, and this is the file system of the image, and this is the states. So and you can also see the images, all the images, volume, to get the persistent state. We will see this in detail, and all the builds. And this is the basic version. If you did not install, you can install this Docker to run the application. So let's go back to the slides. Okay, so here we will create one simple application to demonstrate how Docker can build and run a program without needing the language runtime or SDK installed on your host machine. So this is the simple. Open the Visual Studio. So I already created one simple console application. So there is nothing, just one main program. And how you will add the Docker support to this project. So here you have two options. Whenever you create new project, you will create new project. You can go with the name. You will give name. Then here you can see that framework, and you can see here enable container support. When you check this, it will add the Docker support. And here is the container OS, so you can choose the Linux and the Windows. So I will go with Linux, and here is the container build type. So I have a Docker file. I will select the Docker file, and you will click on the create. So when you create, the project will the Visual Studio will be add the Docker file in default. So but if you don't have Docker file in start, you can also add it to existing project as well. So you will click on the right click, and you will click on the add, and you will see here Docker support. So when you click on the Docker support, it will ask for a few options, like I will go with the Linux, I will go with the Docker file, not the .NET SDK. And here is the container image distro. This is the engine type, so I will go with the default one. And this is the build context. This is the path where this is the root path of my project. So I will create the Docker file in the same root level. So I will click on the OK. So you can see here one file is added, which is the Docker file, and here is the detail of the Docker. So it's a multi-stage. I already discussed the multi-stage, why we need a multi-stage. It's for production, to get the image smaller and production ready and secure. And you can see here, first it will get the .NET runtime for us, and the working directory is the current. This is the image working directory, and this is the second build stage. It will get the .NET SDK 9.0, and this working directory for this is CRS, and it will copy from this is my current project path, and from my current project path it will copy the file into a simple example. It will create the new folder, and it will put here. And next is the publish part. It will publish, and final stage it will run the DLL.NET run. You can see here endpoint.NET run. So this is the example. If I run this, you can see here, you can see this option container Docker file. When I run, it will run the application. Currently you can see here, if I run this application, so it's run. You can see here, when I open the container tab, you can see here the application is running inside the container. So this is how you can add a Docker file to your Visual Studio project. So you can see here, this is the same code Docker file I created in the Visual Studio. So now we will discuss the different stage in detail. Like this is the multi-stage build. So the first stage is the base. The stage one is the base. You can see here it's a runtime. What is the purpose? Provide lightweight runtime environment, only the .NET runtime, not the SDK. So you can see here we separate the .NET runtime from the SDK. So it's a multi-build. So first is the base. And image usage, we are using the runtime image, contain just the N of .NET for the .NET application. And what is the user app UID? You can see here the second instruction. Run the container as a non-root user security. UID is expected to be set externally. So you can set this externally, the UID for the security purpose. And the other is the working the directory instruction. So we have set working directory where the app will run. So it will set the directory. So this is the first. The second is the build stage. You can see here the build stage is compile the application, image usage. We are using the SDK image, that restore, build, and publish. And this is the steps like copy project from separate optimized Docker cache, restore, copy, and build command. And the third one is the publish, prepare the app for deployment, like .NET publish, and other instruction like use host, app host false. So you can see here, if I go to the publish is using the build configuration to release, and they have some instruction as well, like use app host equal to false, and it will use the .NET publish. And the final stage is the actual runtime container. Based on the base stage runtime only, no SDK, it will only use the runtime. Copy publish file from the publish stage into app, and set the setup command like .NET run .NET simple example.dll. You can see the final one, working directory app, and it will copy the file, and it will run the DLL. So this is the multi-stage build. I explain each stage in detail, and Next, why we need multi-stage? If you build everything in one image, the final image could be include the SDK and build file, make it huge. The size will be huge, so which is not useful for production. So this approach, like the multi-stage approach, use the SDK image only for building and use the runtime image for production, which is lightweight, faster, and safer. So this is the purpose. So I will recommend to use the multi-stage Docker file. Okay, so next is the building, how you can build the Docker file. So this is the build command, docker build slash dot slash then t sample app. So here is the explanation. The Docker file, the command to build an image from a Docker file, and the dot / specify the Docker file is in the current directory, and comma t simple example, take the new image to the name, specify the name, and take are used to name and version image. So this is the type of build command. We'll write docker build dash / t and then you will give name. So when you click enter, it will start building. So you can see here the image is built. So this is how you can build your image. So this is the build command. And the next is all image name must be in lowercase. So you will follow this rule, like lowercase. You can also run this command like docker images, that will give you all the images list. For example, if I go here and run the docker images, it will give all the images. You can see here, this is the simple example, is the latest image I built. So this is about the images list. You can also check from the Docker desktop UI as well. Next, okay, next is how you can run. After building, you will run the Docker image. So this is the command, docker run -- name. You will give name to your container, first container, and this is the image name, simple example. So you can say this create and run a new container named firstly from the simple image. The program output, this program run in a Docker container will be displayed. So this is the run command. So how we will run, like docker run -- you will give name my first container, and this will be the image name, example container. So next we will see list container. There is two command, like docker ps, it will list my running containers, and docker ps -- all list all the container including those that have stopped. So let's see these two command. Okay, so first I will check the docker ps. So you can see here, this is the current running, there is nothing. So let's write the other command, docker ps -- all. So you can see here one image is running, one container is running. This is the container id, the image name, the command, and created that, and this is the other information. So next we'll see restart and stop container. You can also restart, docker restart container name. This is the restart command, and here is the other removing and stopping container. You can run docker stop my container. You can run this command in PowerShell. And the other one is remove a container, remove an image from your local registry. So this is some other command you can use in your this is the text source tag and target image. This command attach a new tag to an existing image. Tag or alternative name for an image. Tagging is the first step to prepare an image for the pushing to registry. So this is when you want to push the image to registry. So you can use this by tagging name. Okay, so this is how you can like push and pull images. Like you will need to know the registry, like docker. You must use the tag, like docker tag my image. You will push to that repository. It will attach a tag to that image when you visit the repository. So you can see here the tag. So you can also push to the first you will tag, and then you can push to the like Azure. If you have Azure ECR, you can push to that. So you can see first tag and then push. Pulling an image, you can use this command, docker pull register URL of the image. So this is how you can pull the image. Logging into registry, if you are using Azure, you can use AZ login. It will require username If you successfully log in, you can use the login name, or you can mention the registry name. So another thing is that like Visual Studio, if you are using Visual Studio, you can use Visual Studio provide the Docker support for your application. Like I already mentioned this, if you are in the Visual Studio and if you click on the solution add, then you can see here Docker support. So this is how Visual Studio provide you the facility to add a Docker file. And if you are creating new application, you can also add the Docker support as well. This is a new project. You will select type of your project, then you will give name to your project, and in this step they are asking enable Docker support. So this slide is about this information, real support for Docker. We'll see the important command practically. So this is my simple console application that will run. It will show me the message service is running at port 8080, and it will run after a 10-second delay. So let's see the output in the locally. You can see here it will check, it will run after 10-second delay. So it's running locally. So now we will run the same application inside Docker. So how we will do this? We already have our Docker file. You can see here this is our Docker file. So how we'll run, you will open the PowerShell. So the first command which is to build. So how to build this image first? So first I will run the build command. Here you can see Docker build t my .NET app, and this will be from the local directory. So I will add the dot. So you can see here it will start building. So it's completed. So now I will go to the Docker desktop application. So here is no container. I will just check the image. So you can see here the image is created, but you can see here the tag is latest. So if you want a customized name, so how you will give the customize tag? So for this you will use this command, docker build -t my .NET app, and here you will use the tag, for example v1-0 and the current directory. So it will use the customized tag. So now I will go back to the images, local images in my Docker desktop. You can see here they use the customized tag name. So you can use this command to give the customized name. So you can see here image is created, but it's not running. So next we will run the container. So before this there is also one other command. If you want to check the progress during building the image, so you can also use this command, docker build t then name my .NET app, and then you will use this progress equal to plain and current directory. So it will show you the progress beside building. So this is the three way you can use. And now how we will run the container. If I go, there is no running container. So I have image but did not run any container, created any container. So how I will do this? So I will use this command, docker run, and the image name. So my image name is my .NET app. Okay, so it will run. So you can see here the application is running inside Docker container. So for verification I will go to the app. So you can see here that the container is running. So you can see here the container is running, but it's a random with random name. So how we will give the customized name? So for this you will use I will stop container. Whenever you stop the container, it will change the state. You can see here it now stopped. So how you will give the customized name? So you will use docker run dash name, and then you will give the name to your container by container, my container, and this is my image name, my .NET app. So you can see when I run, it will run, but it will use the customized name. So you can see here the name is changed from any random to the custom name. So this is how you can run the app. So next I will add a tag, and then I will push the image to the GitHub repository. So first of all I will give a tag so to the image. So how you will give the tag? because whenever you push the image to the Docker Hub, you will need tag to attach with the image. So you will use this command docker tag and then my .NET app, my.NET app, and then you will use the username of your GitHub account. For example, if I go to the this is my GitHub Docker Hub, Docker Hub repos list. You can see here is the repo list, and this is my username. So I will use this username with the tag. So I will use ENGR Abdullah. So this will be the, and then I will give the repository name, my docker.net app. Then I will use the the tag. For example, I will give latest. You can see here the tag is added. Now the next step is to push the image to the Docker. So first of all, if you are did not log into the Docker, so you will use this command docker login. So you can see here it will try to log in to my account. So if you did not create account, you will create account in the Docker Hub. Once you log in, then this terminal will be automatically attached. Okay, now I will push my image to the Docker Hub. So this will be the command docker push, then my username, and then my repository, my .NET app, and then the tag name latest. So it is preparing and it's pushing the image to the Docker Hub. It will take some time. Okay, so it's completed. Now I will verify. So I will just refresh the page. So you can see here the repository is created and the image is here in this repository. So this is the information. The tag name is latest, image type, and other information related to the tag, and the image management. So this is the image here. So this is how you can create and run and push image to the Docker Hub. I hope you will like this video. Thanks. See you in the next video. Hello everyone, welcome back to Practical Serverless and Microservices with C#. My name is Muhammad Abdullah and I am Microsoft Certified Azure Solution Architect. So for this course, this is our agenda to understand the serverless microservices on your architecture, Docker, different type of Azure function, background function, IoT function, and microservices practically, and then Kubernetes, how to work with containers and Azure Container App. Then we will check the security observability for serverless and microservices application. For the whole course, we will focus on the car sharing microservices project. And lastly, we will see the microservices with .NET Aspire. So this is our agenda for this course. If you missed the previous sessions, so please check out the previous sessions. So in this session, session number 6, Azure function, we will discuss the Azure function and different trigger of Azure function. So before I start the session, this course is moving from the theory to serverless and microservices to a practical implementation of Azure function. So in this course, our total focus is to, beside the theory, we will totally focus on the practical work. So to explore and implement different triggers available in this Azure function. This is our agenda for this session. We will explore the triggers, different triggers like HTTP trigger, SQL trigger, Cosmos trigger, and Azure Bus trigger. So we will see this practically with the help of Visual Studio and Azure Portal. So the first one is the Azure trigger. So this is the what is the basic of Azure HTTP trigger. So this is the most common trigger in Azure function. It allows a function to execute in response of HTTP request. So the use cases for this trigger is building APIs, creating webhooks, developing integration. So the core principle, a function method is triggered as soon as HTTP request is received. Whenever the function receives any HTTP request, it responds accordingly. So this is the simplest version of HTTP triggers. So this is what is the advantages. It's easy to use, and it also support the get, put, and delete HTTP methods, and it's also a microservices friendly, and integration we can easily integrate this with other Azure services and third-party library, and it's also a scalable and cost-effective. So the disadvantages, it has the cold start latency, like there will be a delay on the first request. Whenever you hit the first request, there will be some delay, and this is the drawback of this HTTP request. And the other one is the stateless nature. This HTTP trigger has a stateless. Like for example, if you have stateful long running process that need the state to be saved. For this, this is not suitable HTTP trigger. So instead of HTTP trigger, we use the Azure durable functions. So we will discuss Azure durable function in the upcoming lessons. And it's a resource limited function, have limited on execution time and memory. Exceeded these often point to a design issue. So this is some drawbacks of HTTP triggers. And when you design HTTP trigger, there is some authorization level, like HTTP trigger allow for different level of security using authorization key. Like we have anonymous that need no access key, and we have function or function specific key is required, and the other one is the admin that need a master key. For example, if you go to Azure portal and open the app function app keys, you will see the master and the default key. So you will need this key to be work with HTTP triggers. So few questions like when to use HTTP trigger. So this is very common question, like when you will use the HTTP trigger. Use HTTP trigger for lightweight stateless function that respond directly on the web request. For example, if you have a REST API, you can use the HTTP trigger. Webhook handle real-time notification integration, like driving a connection between the different services, and you can also use in case of prototyping. So this is some use cases. Now we'll go back to the actual code of the HTTP. So we will focus on one scenario, like as I share this in start that we will use the car sharing microservices in this project. So this is the part of the HTTP trigger, a car sharing application with a car holding API that use the Azure function. So we will see this in action. This is the one solution, and it has different triggers. So the first trigger is the HTTP trigger. So I created this Azure function based on a HTTP trigger. So you can see here this trigger, this app has different type of functions like create, read, and update. Then we have delete. So this is for CRUD operations, CRUD functions. So this is for Swagger OpenAI setting, and this is important, like the HTTP trigger. This is the Azure function based on HTTP trigger, and this is the Azure. I already discussed like HTTP trigger has three type of authorization, like admin, function, and anonymous. So this is the Azure function level, and it's about post, and this is the root of this application. Okay, so it receive the HTTP request, and it process the HTTP request based on our requirements. So currently there is no implementation, actual implementation, just we are logging some information. So this is the create. Similarly, we have read, update, and delete with same authorization level, and each have their type, delete, then read, and create. So to run this, we have some information, like we have configuration for this. This is the configuration, OpenAPI configuration file, and we have app setting.json file, and we have services dependency.json, and apart from that, there is no other, and similarly we can also have this, we can also configure the connected services to this configuration, this Azure function as well. But there is no currently there is no such thing. So just to show you how HTTP trigger works. So I will run this in front of you. So I select car holding as a startup project, so it will run. So you can see here it's now running, and you can see here we have create, delete, read operations, and this is the link of the Swagger. So this is the Swagger UI, and we have different post, get, put, and delete method. For example, if I want to test this read one, it's simply returning the information. So this is about how practically look like the HTTP trigger. Okay, so implementation, I already shared the implementation with you. The simple code provide for HTTP trigger function to handle standard CRUD operations, and you can also, I will share the source code with this course as well, so you can check out the code as well. So the next trigger is Azure SQL trigger. So the basic of Azure SQL trigger is a function trigger that is invoked as soon as any change happens in the SQL database. For example, insert, update, delete. So the key requirement, this trigger requires SQL Server change tracking to be enabled on the database and specifically on the table side. So I will show you this. So you will on the tracking for the database and a table side to get advantage of the SQL trigger. So the purpose, enable real-time data processing and integration based on database changes. Whenever anything happens in the database, any table, so you can trigger this this Azure function. So it used for real-time processing, scalability, and cost efficient. Provide the same benefit as the Azure function by scaling only when needed and it being cost effective. And integration, great for integrating different applications based on the database events. So its advantage is a little bit complex in setup and latency. You must consider potential latency issue and design. You need to decide if this trigger is a better solution than a simpler option like a timer trigger. So this is about your requirements. So you will decide based on your requirement. It's suitable, SQL trigger is suitable or timer trigger is suitable for you. And example audit changes. So I will show you the SQL trigger based example in Visual Studio, but for this you will need to create one SQL Server database. For example, in my case, I will go with car sharing DB, and you will create one table, car holding in my case, and you will enable. I will also give you a script to enable tracking, and you will also allow IP if you have a SQL Server. So you will also allow the IP as well, or Azure portal, and I created one specific resource for this course. So you can see here I already created one SQL server and the other one is the database. So these two things is needed. First you will create SQL server, and how you will create, I will show you. Like for example, you will go to the home page, you will search SQL server, and you will click on the create, and you will select the subscription, then resource group you are using, and you will give any name to a server, and you will careful while selecting the package. Like for example, I will select with SQL server authentication. You will give password and confirm password, and you will go to the network security. You will keep it default. And you can see here I will go with I will not use Microsoft Defender for now, and you will give the name, and you will create. So this is how you can create. After creating a SQL server, you will add the database, SQL database. So you will go to the database section, you will create the database, and here you will select the database name, you will select the server you created, and you will select the, if you are using SQL Elastic Pool. So I'm not using, so click no, and it's for development purpose. And you will select local redundance, just for this is just for the learning purpose. So I will go with local redundant, and this is the storage and compute. So I will go, so you will select the basic version just for the development purpose. So you will be careful here while selecting the workload for your application. So once you create the SQL server, you can open this in the SQL management, SQL server management. So you can see here I already created, and I am connected with this server. So how you will get the connection string? So you will go to your resource group, and this is our server, and you can see here you will go to this is the name of the server, and now I will go to the database. So this is my database, and this is the connection string. So you can get connection string from this part. So this is done. Now you will connect with the server, and you will change the database. So this is our database, car share DB. So what I'm doing with this script, I'm just set change tracking on. So you will need this to be on for this database, and you will also create a table. Okay, so this is two things. You will enable tracking on the table side as well as on the DB side. So you will need this script to be run. So once you run this script, the tracking will be enabled for this. Now I will go back to the Visual Studio. Now I will run the other part. Like for example, this is the this Azure function is based on like SQL triggers. You can see here, this is Azure function, and it's based on the SQL trigger, and it's accepting, this is the car holder, this is the table name, and this is the connection string, and it will accept the list of the read-only SQL changes. So this is the changes list, and you can process the changes according to your requirements. For this, you will add this local setting .json, and you will need this property to be added, website site name, which is the audit app. And apart from that, if you go to the connected services, you can see here you will connect the SQL database here. So you can see here you can connect. I already created the car share DB, so you can also edit. For example, you can select your database from your subscription as well. For example, this is our database I created on the Azure portal. So you will select this and you will go next, and then it will be connected to your Visual Studio and this Azure function, Azure Service app. And you can also manage the secret in this secret.json file as well. So if I go to the manage secret session, this is the connection string I will get from the portal. But I already show this. You can see this database, and you will get this. Okay, so this is about the SQL trigger Azure function, and I will go back to the audit. So you can see here I will run this application. Let's go select as a startup project. So now I will run this application. Okay, so now it's running, the application is running. Now I will add one data. For example, I will insert one record to the table. For example, ID 4, and this is the Abdullah. So I will add one record. As soon as I add the record, I will select the database to run the query. Okay, so record is inserted, and you can see here it's triggered, and I will run, and you can see here this is the record is added. The new record is added. So you can see here, this is how the Azure function, you can see here this is the SQL changes, operation 0 item, this item is added. So this is how the SQL trigger Azure function work. I give the whole changes, how you will do the all changes required for this function. Okay, next we will see the Cosmos DB trigger. So it's a powerful feature that allow a serverless function to be executed in response of to any change in your Cosmos DB changes. Whenever you add any data to the Cosmos DB, you can trigger this Azure function, and the trigger is invoked automatically when item is added, updated, or deleted in DB collection. And it's also enable real-time data processing and integration similar to a SQL trigger. And it's data flexibility as well. Cosmos DB offer more flexible for handling non-structured data. So SQL trigger is used for the relational data, and this one is not non-structured data. Make it ideal for type of data that would be difficult to handle in a relational database, such as car telemetry data. So this is some advantages: real-time processing, data flexibility. So it's like for the non-structured data we can use this, so it will be a flexible option. And the one of the disadvantages is that it's very expensive, so it's crucial to carefully consider the cost of the solution when you are developing. So this is example car telemetry. So there is one scenario: a car sharing app use Cosmos DB for high performance globally distributed storage of real-time car telemetry data, such as user activity log, location. So for this, for development and testing, we can create a new Cosmos DB trigger in Visual Studio, and we can also set up the local setting as well for debugging and testing. Like we can use the Cosmos DB emulator as well. This is the example of the Cosmos DB trigger. So this is the code. There is one function, Cosmos DB trigger, and this is the database name, container name, DB connection, and the lease container name. It's also used for a container used to manage leases for processing changes. So this is the simple trigger, Cosmos DB trigger. So first you have like a few options. So you can use the emulator. So you will install the emulator from, for example, if you go to this link, microsoft.com, you can see here what is the Azure Cosmos DB emulator. So you can download, when you go down, you can download the emulator as from this page. So I already installed. Another option is you can also use the Docker option as well. So you can install, you can get the image of this emulator, DB emulator, and for both Linux and Windows. So it will provide you image as well. And if you go to with the emulator desktop application, so you can see here I already installed the Azure Cosmos DB emulator. So when you launch the emulator, you will see something like that. So you can see here it will run on this local host 8081, and it's the Explorer, and this is the index page. So to save this cost, I will suggest use this emulator, and it will perfectly work as like a real Azure Cosmos DB. So first of all, according to the code, this is the code. So first I will need some connection string. So you will need the Cosmos DB connection string. So from where you will get this connection string, once you run the emulator, when you go to the quick start page, you will see this primary connection string. So you will copy and you will paste this in your code. So this will be the connection string. And the second thing is the code, actually the code. So this is the database name. So you will create one database and one container with the same name you mentioned in your function. So when you go to the Explorer, you will click on the container and you will give the name. For example, in my case, I have this will be the database, and the container ID will be, this is the container ID, and this is the partition key. So the partition key will be like the car/id in our case. So I already created. You will click on the OK, and once you create it, you will see this item in the list. So I'm the container, and this is all the list we have in the this item list. So this is the item list. Okay, so this is the program, and now I will run this application. You will make this as a startup project, and now I will run. And this container, it will if this is exist, it will not create it. If this is not there, it will create the list. For example, this, you can see here, this is the extra container created if this is not there. And it will also accept the input, like what changes made in the Cosmos DB. It will accept all as an input. And this is the object, like we have car ID, we will receive the car ID, and we will print out the car ID, and this is the modification count, input.count. So you will bind this read only list with this class. So now I will run. So now the function is now running. Now it will track all the changes happening in the emulator. So now I will go to this emulator, and I will add one other item. But for before this, this is our data, sample data, and this is, for example, car number 5. Okay, so this is the same. We will keep this date and data same as it is. So I will save. Now I will go back to the emulator. Now you will click on the item, new item. So this is the item list. Now I will go to the item upload. Now I will select the data file. I already have a data file, and I select it. Now I will upload. So it's uploaded. Now I will check the log. So you can see it's the trigger is now hitting, and if I go 1, you can see here the input count is 1, and it's getting 1 item. Okay, you can see here this is the same data we are passing from the file. So now you can see here this is the data changed in the one item is first item car. You can see here this is the same car ID I am passing from the file. So this is how the Cosmos DB work. And there is one important distinction, a critical difference from the SQL trigger is that the Cosmos DB trigger only monitor insert and update, not the other case like the delete. No deletion case. This trigger does not monitor deletion event. If you need to track deletion, you will need to implement alternative solution. So this is one of the important distinction. So now we will discuss the Azure Service Bus Trigger. A serverless function is triggered by messages in Azure Service Bus, a powerful message broker. It's a message broker for microservices communication. So we will see this in detail. So a Azure Service Bus have two model. One is quiz and the other one is the topic. The quiz one-to-one relationship where a single receiver processes each request. They ensure reliable order delivery and are great for decoupling application and buffering messages. So we will see this in practically. And the other one is the topics, which work on the publisher subscriber pattern. It handle one-to-many relationship where a single message can be delivered by multiple subscriber. They are used for complex workflow where different services need to be react to same event. And the topic can also be filtered to route specific messages for the specific subscriber. So if I go to the portal, you can see here this is our resource, and I created this resource for this course. And here you can see here I have one is a service bus namespace called car share service bus. When I open this service bus, you can see here this we have entity, we have quiz and topic. So this is the two model I'm talking in this slide. So we have two one-to-one relationship, and the other one is work on the one-to-many publisher subscriber patterns. And this is the next slide is Azure Service Bus Trigger. Benefit, it's a reliable, secure, and we can do integration easily. It's very flexible. And about the cost queue are generally cheaper than the topic. So we will see this as well. The topic, if you want to use the queue only, so you can use the basic with basic subscription as well. But if you want to do both the queue and the topic, you will need a extended and premium package. You cannot do a topic with the free version. So choose the model that fit for your need to manage the cost. And next is the apart from the Azure service, we can use the other option as well, like Kafka and RabbitMQ. If you are working inside the Azure environment, so the Azure Service Bus is a great choice. And if you have like massive amount of data, like data streams, so you can use the Kafka, and you can also use the RabbitMQ, and it's easy to use and highly flexible, and it's a lightweight, and it make very versatile options as well. So this is some other option you can consider while working with the messages bus, message broker. And in our code example, we have one scenario when a user search for a car, a message is sent to a service bus topic named car seeker request. Like the purpose of the topic, a topic used because multiple microservices like the route planner, the notification service, and need to react to the same cars, the same event. So for this we will create the dedicated Azure function to monitor. So if I go to the code, Visual Studio, there is one Azure function, route planner, and we have one car seeking class, and we have one function. And you can see here that this is the SQL based trigger, and this is the topic, this is the topic, and the other one is the subscription name. We will see this topic and subscription name from where you can get this. And this is the messages. You can receive the messages. For example, I'm receiving this message, and I'm getting the message and ID, message body, and message content. And the other one is the service bus message action. Whenever it mark the message, like when it's successfully processed, it remove from the queue. So this is needed to complete the message. And so you will go to the we will go to the Azure portal. So this is our resource, and here I created one. You will create one Azure bus, and you will create. Once you create, you will have these two model. So for this example, I will use the topic because the subscriber will be multiple in our case, so I will use this. So the first thing, you will create one topic. So you will give name to the topic. So for in our case, we have a car seeking request according to our code. You can see here this is the topic name, so I will use the same topic name in the portal as well while creating the topic. You will just give name and hit the create, so you will see this in the list. Once you have this in the list, you will click, and you will create one subscriber. You can see here on the left side I have one entity subscription, and you can see here I have only a route subscription. If I go to the code, I have a route, and you will create subscription. You will give name, and you will see you will just give name and create. So but I already have created and the subscription, so I will not create it again. So now the other thing, you will use the Explorer to send a message. For example, this is our Azure function. Here is the local app setting. This is the connection string of the car share bus. So you can get this from the you will go to the, when you create the bus, you will get this connection. So you can see here in the left side, I have setting. Under the setting, we have share access policy, and this is the default route. And when you click, you will get the connection string. So you will get this primary connection string. This is needed, and you will put it in this setting. So once you get, you can now run the application. Now I will run the route planner. So now it's run, Carseeker is run. Now I will send one message from the portal. You can use other tool as well to send a message, like you can create the C# console application. And for now I will use the same Azure portal. So now I will go to the topic, and I will click on the topic. Now you can see on the left side, you can see the Service Bus Explorer. Now I will click the Explorer. And now you can see here the send message option here. So I will click, and here I will write some message. Service Bus Explorer. So now I will send. Sending completed. Now you can see here it's automatically triggered, and we can get all the information inside the message. So this is the message ID, the message body, hello from the Service Bus Explorer, and this is all about the how you can receive the information. So this is all about, you can see here, this is all the information, the message ID, body, and this is the end of this session. I have one question for you. What are the benefit and concern associated with using Cosmos DB trigger in the Azure Function? So this is your assignment. So see you in the next video. Thank you. Welcome back to Practical Serverless and Microservices with C#. My name is Muhammad Abdullah, and I am Microsoft Certified Azure Solution Architect. Today in session number 7, we will discuss background function in Azure. So what is background function in Azure? We are facing one problem, and the problem is cloud computing solution. In cloud computing solutions, especially PaaS, often require background tasks to run independent of user request. So to fix this issue, we use serverless computing from Azure Function that provide us function that run in background. So we have different type of background tasks. For example, we have timer trigger, blob storage trigger, and queue storage trigger. In this session, we will discuss these 3 background tasks. So the first one is the timer trigger. So why we need the timer trigger? The timer trigger help us execute a function at regular schedule interval. For what is scheduling? The scheduling is defined by chronic tab expression, which is a time-based format similar to cron expression. You can see the example below. We have seconds, hours, days, months, and a day of week. So we will discuss this in detail. Here is the table that define the chronic tab expression. So you can say we have second, minutes, hours, days, and month. And for example, if you want to run any task every second, so you will use the star. So there is 6 star, or 6 star mean every second. And if you want to run any job every minute, so you will add 0 at start and then 5 star. So this is the this job will run every minute. You can see the other type as well, like if you want to run every 5 second, if you have run any job on any specific time. So this is very flexible. So it will you will create expression based on your requirement. We have one web application that create or generate us the chronic expression for you. So you can visit this website to create chronic expression. So when to use timer trigger? So if you want to take a backup, routine maintenance, periodic data processing, or generate schedule report, so in this scenario we can use the timer trigger. So there is few advantages as well. So we'll discuss this, here this as well very shortly. Like it's a simple form of Azure function. When you want to do a background task, this is the simplest one. And execute function at regular intervals. So this is the flexibility. And the disadvantage is if no work is needed at the scheduled time, the function will still run, leading to unnecessary cost. So this is one of the disadvantage of timer trigger. So how to create timer trigger inside Visual Studio, I will show you step by step. So here you can see, you will go to the new project, you will create new project, and inside this template window you will see Azure function. If you don't see the template in the recent section, you can search Azure function in the search bar, and you can see here this is the Azure function. So you will give name, so this is the name of the Azure function. You can see here you can select solution name, location, then click select. In the next video, in a window, you will see the function framework. You will select any framework based on your requirement. I will go with .NET 9, and here is the function type. So you can see here you will select the timer trigger, and here you will use this expression. So you will define the expression based on your requirement. After creating expression, then you will create, you will click on the create button. So once you create, you will see something like this. For example, I already have a function, so I will not create it again. So you can see here, this is the class, a simple function, this is a constructor, and this is the function, the timer trigger function. You can see here, this is the expression, and this expression show the trigger will run every 5 seconds. After every 5 seconds, this logic will be executed, and inside this function, I'm just logging the information. So this is how you can define the timer trigger. So if you run this timer trigger function, you will see something like this. For example, you can see the function is run in run mode, and you can see here this is the information. It will run every 5 seconds. So you can see here it will run every 5 seconds. You can see here the information is again printed. You can see here this is again printed. So this is a schedule. It will run in background on the based on the expression. Okay, next we will discuss how you can monitor your Azure. Once you define the Azure function, how you will monitor. So Azure portal provide you a different type of monitoring tab, like you can use the Azure monitoring. You can monitor your function in the Azure portal to ensure that it's running properly. There is one annotation tab. This tab provide a quick overview and basic detail on the number of time your function has been executed. It will show you number of time and some other information. And Azure monitoring log for detailed information. You can use Azure monitoring log. So for example, here I attach one screenshot. This is the Azure monitoring log where you can run your query based on your requirement, and it will show you the result against that query. And here is one annotation tab. When you open any Azure function and you will go to the annotation tab, you will see the count, number of execution. You can see here success count is 5 and error count is 0. So this is the annocation window, and this is the monitoring application inside performance. This is the performance view where you can check the performance of your Azure function. So it provides like different two views. One is performance view, help analyze performance issues and error, and the other one is the live metric view, provide a real-time view of your function performance for debugging. If you want to debug, you can. This is very useful information you can use. So in our car sharing scenario, we can also use timer trigger. For example, a car sharing service need to process billing once an hour but not on Sunday. So to cover this requirement, we can use the timer trigger. And the timer trigger is the best solution in this case to automate this process. So here is the example how we will get this. For example, you will create one Azure function of type timer trigger, and here is the expression that will be run once in an hour but not on Sunday. So this is the expression used for to cover these requirements. Here is the detail of this expression. In start we have 0 at the start of the second, then we have at the 0 at the start of the minute, and this is the time between 8 p.m. to 5:59 p.m. and The star is represent the every day of the month, and the second star is representing every month, and 1-6 it will represent from Monday to Saturday. Now we'll see blob storage, when to use a blob storage and what is the advantages, disadvantages. So first, the basic of the blob storage is that it's a Azure function that is executed in response of any change in Azure Blob Storage. If you upload, if you update, or if you delete any item from the Azure Blob Storage, this trigger will be hit. So what is Azure Blob Storage? It's a highly scalable and cost-effective services for storing unstructured data, like images, logs, backup file, and blob stand for binary large object. So it scalable, it handle large amount of data. We can access via HTTPS and HTTP, and we can also do a seamless integration with Azure function to automate any process. If you using local development, then you can use the Azure emulator, and you can also use Azure Storage Explorer for local development. So when to use, if you want to do image processing, we can use the blob storage, blob trigger, and for data analysis we can use, and real-time and batch processing we use the blob storage. And here is some advantages, disadvantages. Advantages are data handle, a large amount of data handled by the blobs trigger, and it's scalable. And disadvantages, it's like the pricing model is based on execution count and data processes, so you will be careful while selecting the pricing plan. And there is a latency problem as well. Depending on the app service plan, there can be a delay between a file being uploaded and the function being triggered. So this is some disadvantages. So now I will go to the Azure. So here you will create Azure storage. For example, I created this Azure storage for this course. If you did not create a storage yet, so you can create by clicking this create button. Once you create, you will fill the form. You will select the resource group. And for example, I created this resource group to keep all my resources in a single group. So it's very useful. You will give name, then you will select the Azure Blob and Azure Data Lake. So I will go with this. If you want only Azure file, so you can select the other option as well. You can select the standard instead of premium, and this is you will select the local redundant storage. After that, you will create and review. So this is some thing about how you will create the storage. Once you create the storage, you will see the storage in your list, and here you will see some information, like you can see the data storage. So this is important. Here you will see the container, file share, queues, and table. So after this, the important thing is the access key. So here you will find the connection string to this storage. So you can use the key 1 and key 2. It's up to you. And after that, you will create one container. So for example, in our car sharing application, whenever any driver upload their driving license, after uploading, we will trigger the Azure queue trigger, and we will process the document. Like we will extract the information, then we will analyze, we will do hashing. After hashing, we will delete the document. So for this purpose, the queue trigger is suitable. So that's why we will use the queue trigger in our example. So I created one container for this purpose, driver license upload. Whenever any user upload any document, the queue trigger will be hit. So this is about how you will create the container as your storage. Now you will create one application. You will click on the Visual Studio. You can see here I will create new project. You will search Azure function. Here is the function, and then you will give name to your application, for example, driver. Also, you will select the location. I will select in our location. So I will select the location. This is the name, and it will solution name will be the same. I will click next. After that, you will select the framework. I will go with .NET Add, and here you will select the trigger that you want. I will go with the queue trigger. Sorry, I will select the blob. I will I will select the blob trigger. After that, here you can see you can select use Azure for runtime storage. You can give name to connection string that you want, and you can also select the path, the storage, the container path. So here. What I will do, I will add the connection name. For example, I will use this connection. So this will be the connection name, and this will be the path name. There are two things. This is the container name as I created in the, you can say this is our container name, and the other one is the placeholder. So we will receive the file to process. After that, I will select next. So you will select one option out of three. So I'm using the actual storage, so I will select the storage account. If you are doing local development, you can use the other option as well, the Azure on container, Azure emulator. So I am doing the actual development, so I will select this. Then you will select the storage account. It will you will need to log into your Azure portal, and here is all the storage accounts. So I already created one storage account, so this is my storage account for this course. So and I will create next, and then you can see here this is our connection string name, and this is the endpoint name. Now I will go next, and it will set up the secret for us and the other packages, and once you finish, it will create the Azure function. Now we'll see queue storage trigger, a function that is executed in response to message placed in Azure queue storage. When any new message is added to the queue, it will trigger. So this is the basic of queue storage trigger, and it works on the FIFO best principle. First in, last out, and it ensures messages are processed in the order they are received. So it's used to make the system decouple, and here is some benefit, like we can use this for asynchronous processing, like it's enable decoupling synchronous communication between two different armored services, and it can handle large amount of messages with automatic scaling, and it also reliable and fault tolerance, like it guarantee each message will be properly processed. So this is some benefit of using queue storage trigger, and using a queue storage trigger allow developer to focus on the core business logic, as the underlying infrastructure is handled by the cloud provider such as Azure. So you will only focus on the core business logic. So this is the benefit of using queue storage trigger. And advantage is efficient messages handling and decouple architecture, I already covered in the previous slide. And some advantages: you should be careful while selecting the plan. The pricing model is based on the number of execution and data process, which lead to unexpected cost. And other disadvantages is error handling. Developer must implement mechanisms such as retry and error handling to manage high load or transient failure. So you should be careful while implementing mechanism like retry and error handling. So when to use queue trigger? Best scenario, queue storage trigger is reliable and efficient choice for the processing a queue task. Whenever you want or need a queue task in your application, then this is the best tool to use, such as order processing. In e-commerce, we have order processing. In that case scenario, we can use the queue trigger. And if you want to do a background job scheduling, so it's best choice. And if you want event driven notifications, so queue trigger will help you in this. And for a practical, we will see one example in our car sharing example. For example, in case of best match scenario microservices, there is one scenario that is the car sharing application has a best match microservices that need to be triggered whenever route manage occur. Whenever any route manage is occur, then we will use this my best matches solution for this. Route messages are sent as a JSON message to Azure queue storage and named new message. So this will be the queue name of the queue. The new message will be the queue. A queue storage trigger function is used to process these messages. So to do this example, I will show you step by step how you will do this. So let's go to the Visual Studio. So first of all, for a local development, you will use you will install the this one tool, Azure Storage Explorer. We will use this storage for emulator purpose. Okay, and you will also need one Azurity as well. For example, if you go to see your control command prompt, here you can see this is the command prompt, and you will use the Azurity. We will use Azurity plus the the storage explorer. If you don't have any Azurity installed, so you can use this command to install the Azurity. So I already have Azurity, so I will not run the command again. So to run the Azurity, you will use this command, Azurity silent mode location. This is the location of the Azurity, and once you run, you will see these messages like, for the blob, when anything happen in the blob, it will listen at this port. When anything edit or updated in the queue, it will listen to this one. And if anything happen in the tables related, so you can use this. So this is all the three, blob, queue and table. It will listen on the respective ports. So this is the first step. You will install and you will run this command. Once you install, then you will open the Explorer. Once you open the Explorer, you will see something like this. If you are new to this Storage Explorer, how you will connect, you will click on this switch button, and here is few options. So you can see here, I will select local storage emulator. So I am not using the actual Azure services now, because this is in development stage. So to save the cost, I will use the local storage emulator. So you will click on this, and here you will give name, account key, other information. Then you will click next. After this review, you will review and you will click connect. So it will connect. Once you connect, you will see this option, emulator attached. So I already connect the emulator, so I already have, and inside this emulator attached, you will see the account storage. So we have different accounts. So I will use this emulator account. So you can see here we have options for blob storage, queue storage and table. So this is the three options we have in the Azure Storage Explorer. So this is something about Azurity and Azure Storage Explorer. You will need this in application. Now Azurity is running and this is connected to the Azure Storage. So next I will go to Visual Studio, and I will create one application, Azure Functions. So I will create new. Then you will search for Azure Functions. You will select next, and you will give name to your function. So based on our scenario, I will give respective name, my best matches, and here is the location of your code and the solution name, and click next. Okay, so now you will select the framework you want. I will go with .NET 9, and here is the queue trigger. So we will see how queue trigger work in reality. So you will select the queue trigger, and here is some option. As I already mentioned that we will use the emulator, so you must check this checkbox for to use the Azurity and for runtime storage account. So I will keep this selected, and this is not needed, so I will not use the container support. Here is the connection string name. So you can give any connection string name. So in my case, I will give the car storage car sharing storage as a connection string name. The second thing is the queue name. So queue name is important. I will give name like new match. So this is needed, so I will select the new match, and here is the configure. You will select the dependency. I will explain you. So you can see here in the Explorer, I will create the same queue with the same name I give to this queue name. So next. So in the next screen, you will select the connect the dependency. So I will use the Azurity emulator. I already explained in the start how you will connect the Azure Azurity emulator. So I will select the second option. If you want the actual Azure storage, so you will select the third option. Okay, so now I will use the Azure emulator locally, not on the, if you have a containerized emulator, so you can use the first option. So I will use the second option. So next you will use the connection string, and this will be the connection string. So remember that if you are working with the emulator, the local development, so this will be the connection string for your application. Okay, so this will be the name, and this is the connection string. So next, here I will unselect all the packages because I don't need, so I will not select this, and Yes, so let's back one thing. I will not save the anything locally. So, so you will click the third option, next, and I will not. I don't need any other package, so I will unselect and finish. So once you finish, the application, the function will be created. Let's close, and now you can see here. If I scroll, it will add all the packages. Here you can see this is the function we created, and you can see here this is the queue storage. This will be the queue name, new match. So I will copy this, and I will create the queue with same name in the Azure storage. So you can see I will come to this point, and I will open the emulator default port with key, and I will click on key, create new, and I will give the same name, new match. So this is about how you will create the queue in the storage explorer. Now I will go back to the code. So here you can see the connection. This is the connection string name. So I will copy, and I will go to the local setting JSON file. So you can see here there is no connection string name, so I will give the name, and then I will use this connection string. This will be the default connection string for local development. So you can see all is done. So all the step is done. Now I will add trigger here, and I will run this application. So now you can see here this is running, the Azure function is running. Now I will send one message to the queue. So I already note down the message to save the time. So you can see here I will open the Explorer. Here is the Explorer queue, and I will click on the add, and here you will add the message, and you will keep all the thing as default, and I will click OK. As you can see here, the breakpoint is triggered, so we can analyze the message we are sending from the Explorer. So you can see here, you can process the message. So this is how the queue trigger works. Welcome back to Practical Serverless and Microservices with C#. My name is Mohammed Abdullah, and I'm Microsoft Certified Azure Solution Architect. In session number 8, we will discuss IoT function. So what is IoT? The Internet of Things is changing how we interact with the world by connecting physical devices to the internet. So IoT is about connecting a physical device, like for example temperature sensor, to the internet. So the challenges of IoT is scalability. Delivering scalable IoT solution can be challenging. So that's why we use IoT Hub. Azure provide IoT Hub. So in this session, we will discuss practically how IoT Hub work. So IoT Hub fix scalability issue, like it's highly scalable, and Azure IoT Hub is a platform as a service solution that provide a robust environment for connecting, monitoring, and managing a large number of IoT devices. So we will see IoT practically in Azure. So I will go to Azure, and if you are new to Azure, you will search for IoT in the search bar, and as you can see, IoT Hub. Hub. So this is IoT. So there is no IoT Hub currently, so I will create one IoT Hub. So you will click on create. So here you can see you will need a subscription, then you will need one resource group. For this course, I created this resource group, RG Serverless course, and you will give name to your Azure Hub. For example, I will give name, for example, IoT car service. So the name should be unique. For example, this will be IoT car service will be my name of the IoT Hub, and this will be the location. You can select nearest location to your customers. So I will go with the South Asia, for example, and here IoT Hub provide different type of tiers. For example, it have free tier, basic tier, and standard tier. So for this video, this is course, so I will select the free, and if you want to compare, here is the comparison for the IoT Hub services. So you can see here there is three tiers: free tier, basic, and standard. And the main difference is the messages. In free tier, it provide 8,000 messages, and the message size is 0.5 kilobyte, And for the basic, it provides a large amount of messages, like 3 billion, and the message size is 4 KB. And this is the table. You can in the standard you can use the device update for IoT Hub and Defender for IoT. I will use the free one, so I will select the free. After, you can see here, when you select the free, it will show the messages. If I select the basic, the pricing and the messages limit will be changed. And then you will select review and create. You will keep other thing as default until you need anything like in networking management and add-ons. So after you will review the pricing and the limit you want. So it will take some time to create. Development is started. Okay, so finally IoT core service is created, IoT hub is created. So when you click on the go to this, you can see visit the resource as well. This is the overview of the IoT hub. You can see the messages on daily basis, the message quota, and this is the connected IoT devices. So after that, once you create the IoT core service, I will add one device. For example, I will create one, for example, car. You can also use other tool devices as well, for example, temperature. So for now, I will create one simple device, for example, car 001. So this is the device. You will keep all the other option as default. So once you click save, it will create the device successfully. You can see here the device is connected. We can also add other device like temperature device sensor, so it's up to you. So now as you can see here in this slide, we will follow one example, IoT device simulator. So in this example, we will create one console application that will pretend like a temperature sensor, and it will send messages to the IoT hub, and after every 5 seconds. And then we will create one IoT hub. I already created, and then we will create one Azure function. Whenever IoT hub receive any message, the Azure function will be triggered. So this is our agenda. So this is the graph as well. We will define, we will have one IoT hub, and it will have one device, and then we will have one console application that will act as a temperature sensor. It will send data to IoT hub. Then IoT hub will send this to this data to the IoT function. And we will define IoT function as an event hub trigger. So we will see this in action. So I created one console application, IoT device simulator. This is a simple console application in C#. So you can use the console application template. There is nothing in the application, just a program.cs, and it will act as a temperature sensor. And you will add this library as well. This is Microsoft provide this library to work with IoT hub in Azure hub. So first of all, I will create one connection string, and from where you will get this connection string, I will show you in the Azure portal. From where you will go to the IoT hub, then devices, then select device, and then get the primary connection string. So we will see this, and after that, I will create one function send message async that will accept device client and message, and after that there will be another one function that will send the message to the IoT hub. And to call this, we will use one main function that will send the message, for example temperature, every 5 seconds. And this is, you can see this is the delay, 5-second delay. So this is the application. Now I will go to the Azure hub. So you can see here there is one device already, but if you want to add other device, for example, I will add temperature temp device 001, for example. You will keep all the thing as it is. So you can see here I added the other device as well. So you will get the connection string. So you will click on this. So you can see here we have different connection keys like primary key, device ID, primary key, secondary key, and primary connection string. So we will copy this primary connection string, and we will paste in the console application device connection. So you will paste it here. So this is done. The first part is done. Now if I run this application, you will see it will send a data message after every 5 seconds. So you can see here, this is the message number 1. It's sent to the IoT hub by using the connection string. This is the second message. So our console application is perfectly working. Now I will go to the second part. So this is the second part of our application. So you can see here it's a IoT function. So here is the function 1. We will define one Azure function. First of all, I will define logger to log any logs, and then I will define one Azure function of type event hub trigger, and this is the queue name, the events name, and this will be the connection string name. So they will process each event. For example, they will accept the events array and it will process each event. For now, just for the demo purpose, I am printing the body and the content of the event. So this is all about the function. So you will do one other thing. You will copy this connection string and you will go to the local setting JSON file, and you will add one other connection string. So from where you will get this connection string. So you will go to the event hub. For example, I will go to the event hub. So this is the event hub. No, this is our event hub, and this is the first event hub I created. And you can see here, you will go to the hub setting. So you can see here, this is the hub setting. Then you will click on the built-in endpoint, and here you can see this event hub compatible endpoint. So this will be the connection string for the function. So you will copy and you will paste in this part. So this is done. So now the function is also completed. Now I will add one trigger here and the other trigger in the console application. So now first I will run this console application, then I will run the Azure function as well. Okay, so Azure function is up and running, and the first message they received. For example, if I go to the this is the function, and you can see here, this is the simulator. It will send one message. So you can see here, it will send one message, and then it will hit the function. So you can see here, this is the function app, and it will receive the event. For example, if I go to this part, so the body is, you can see here, this is the body of the event, and this is the content. So this is how you can communicate your device, the IoT hub, and the Azure function. I show this practically. Go to the if I go to the portal, you can see here, I will go to the portal to check the result. I will go to the devices. This is the temperature device 01, and you will see the IoT hub messages information in the overview section. So you can see here, today we used 9 messages from the different devices, and 2 devices is connected. So this is how you can use the IoT hub. Now we'll see another example from our car sharing application. This will be IoT solution connected to a microservices solution. For example, as you can see in this figure, we will send vehicle data to Azure IoT hub. I already show how you will create IoT hub and how you will add devices, how you will extract the connection string and use in your application. And this IoT hub will use Azure Event Hub Azure function. Okay, and the Azure function will send data to Cosmos DB. Either it will send the data to the RabbitMQ, and the RabbitMQ will send this data to the other microservices. For example, here the planning route microservices, it's subscribed to the messages on RabbitMQ, and the RabbitMQ will send the data to that microservice. So this is the example we will see. So as you can see here, I created one example in C# using Visual Studio. We have one simulator. that will simulate the car. Similar to my previous example, you can see you will get this connection string, and here you can see it will send the data to the Azure hub. Okay, so you can see here I am sending vehicle ID, their location, and speed, car status, battery level, fuel level, tire pressure. So this is all the information we will send. And after sending this data, stimulating this data to the IoT hub, the IoT hub will then send this data to this vehicle tracking function. So what is inside this tracking, you can see here, this is the event hub trigger, and it's using the car sharing IoT hub connection string, and this is the default endpoint messages event hub. This is the default event for IoT hub. And once it's received the data, the first thing it's doing, it's the save data to the database. So this is the simulation. This is just a simulation. For now, we will just print out the message console write line. We will print the speed and the ID. And the second point, it's sending the alert message to the RabbitMQ. You can see here it's a RabbitMQ simulation, and this is it will send the data to RabbitMQ. And you can see here this is the all application, and this is the required types needed for this application. This is the message stamp, this is the geolocation data, and this is the start and end date and time, and this is the basic information message. And this is the vehicle related data like ID, speed, status, car battery level, fuel level, and tire pressure. So I will run this like when you go to the profile. For example, I'm running, for example, two application. You can see here configure startup project, multiple startup, and I'm only the car simulator and the vehicle tracking since I will start. So I apply OK, and you will run. So you can see here the Azure function is running, and this is the simulation, vehicle simulation, vehicle tracking simulation. So it's sending one vehicle, IoT Explorer. So you will install this, you can install this from the any Azure IoT Explorer download. You will search this, and here is the link, install and use Azure IoT Explorer. So you will go to the install section, click on this, open in new tab, and you can see here just install and download and install. So once you install, you will see this you will see the Explorer. So how you will connect, you will click on the connection string. After here you will need a connection string. So from where you will get this connection string, go back to the IoT hub and click on the IoT, your IoT, and now you will go to the security setting and shared access policy, and you will click on the IoT hub owner, and you will get the connection string, the primary connection string. You can see this is the primary connection string I will get, and I will connect the IoT Explorer. So you can see host name, shared access policy, and shared access policy key. Now I will click on save. So you can see here it's added, and we already added two devices. So this is the device ID. You can see here you can check device twin, telemetry data, and the cloud messages. So you can also manage IoT devices from this Explorer as well. Welcome back to Practical Serverless and Microservices with C#. My name is Muhammad Abdullah, and I am Azure Certified Solution Architect. And this is session number 9, microservices in practice. So in this session, we will create route planning microservice for our car sharing application. So this will be our key topic. We will see the detailing the functionality of the route planning microservice. Then we will see the input output communication and request serving logic. Then we will use the Poly library for resilient communication, and we will see also the onion architecture. Onion architecture will be our main architecture for this microservice. So the route planning microservice will store and match user request to travel between two towns or two routes. And the matching logic, about the matching logic, when a route is created, it match it compatible request based on the town proximity and that constant. and new request is created. It's matched with existing. When someone try to reach to other town or their destination, they will create a request, and the route will be created by the driver. So the request and route will be matched. When it's matched, it will show the result to the user. And this will be the life cycle management, like route removal. A route is removed from match when it's close or abort. And the other thing is route extension. A route is extended when it merge with a request, and a request removal when it merge with the route. When any request merged with the route, then it will be removed, and request become available again if merge request is abort. If any route is removed, then we will again the request will be again enabled. And for the cleanup purpose, both request and route are deleted, and after maximum traveling, so we will also delete the request and routes from our system. And for communication, we'll use the publisher subscriber pattern. For this, we'll use RabbitMQ as our message broker. RabbitMQ will be used as a message broker. It's highly portable, and it's not depend on any cloud platform. So RabbitMQ is the best choice. So for this microservice route microservice, we'll use the route planning microservice. We'll use the RabbitMQ. And for message serializer, we will use the JSON. And for our project template, we will use the Azure Core, a minimal API based project template, because it will support hosted services needed for message broker communication, and it also allow to easily expose HTTP endpoint for health check. We will also define health check endpoints to check the health of any microservice. So this is best practice in microservices. So for security perspective, user to microservices security, it will be handled by the ASP.NET Web API technique. Primarily used like JSON based tokens. We will use the authorized attribute to check security of any request. And to service communication, we can use the mutual TLS, but to keep this simple in this course, we will not go deeper in this security. So we will. This is just for you can also use the TLS for service to service security. And about API gateway act as a public facing entry point. So this is in microservices, we have different microservices, and we cannot access the microservice directly, but we can only access the microservice with the help of API gateway. So about the API gateway security, they also handle the HTTP termination, receiving encrypted traffic from the outside world, and also maintain encryption within the private network using TLS or encryption. So this is a best practice for end-to-end security. And to do this, to start practically, first we will create a minimal API project using Visual Studio. I will use Visual Studio, and we will give name route planning to our solution, and we will not select the HTTPS, and we will also add the Docker support as well to our application. So let's get started. So first of all, I will create one new solution. You can see here, this is the Visual Studio 2022, and here I will select create new project. And here I will select the template. You can see here, you will select this ASP.NET Core Web API template, and let's next. And here you can see we will give name to our application. For example, route planning will be the application, and here we will select the location. I will create one other folder. You can also I will also upload the code with this course as well, so you can access the code as well. Code, and select, and the solution name will be route planning as well. So you can see here solution name will be the car sharing, because our main project is the car sharing. Okay, so route planning, and you can see here I will click on the next. So here you can see I will go with latest.NET 9 and no authorization configure for I will unselect, and I will click container support as well. I need a container, so I will click the container, and you can see here there is two type of containers. So I will go with the Linux based container, and I will also enable the open API support, and I will go without controller to keep it minimal. So this is the setting for our project template. So okay, so I will create next. Okay, so the project is created without controller. So this will be our route planning application. So you can see here there is nothing inside. We will remove the extra code uh, like this. Remove this comment, keep this minimal, and I will remove this default code. So you can see here I don't need this weather default coding. So you can see here now it's clear from the unwanted code. This is the app setting file, and this is the program.cs file. So first I will create one folder. I will add one folder. I will give name hosted services. I will give this to hosted services. In this hosted services, we will have three main services that will run in background. So the first one will be the main service. Sorry, this will be the hosted service, and this will be the main service. This will be the consumer. It will consume the messages from the RabbitMQ. So I will create one class, main class. So this is our main class. Then we will have a housekeeping class that will clean up the request and routes. Okay, so you can see here, and the third one will be the output. So we have added three hosted services. So the first one is the main. So we added the main. So we will, it's currently not implemented. So this is just for introduction, what we will add this to the main service in future. So this is the main overview. So main service will be act as a message consumer. And the purpose of this main service consume messages is from RabbitMQ. When RabbitMQ exchange or receive any new message, so this will be triggered in background, and it will do their job. So this will be subscription for this will be, we will create different type of messages like route offer messages. Whenever any driver create new route offer, so we will use this message to the, we will send this message to the RabbitMQ that for example ABC driver created this route. And the second one will be the for the passenger, he will create the request for the route, and for extended route, we'll use this subject, route extension and modification. This service will also do the route closure or cancellation, and we will also, this service will also handle the real time vehicle tracking, and we will also do the error handling, track error count for the health monitoring. So this will this service will be responsible for these things. And this output sending service, this will be act like a message publisher. So it will process each outbound message available in a queue, and publish messages as well. So the key feature will be batch processing with configurable batch size. So we will it will get the batch size from the app setting. We will configure the size in the app setting, and it will get the size from the app setting, and it will process accordingly. And we will also add the poly library as well for the resilient try catch and circuit breaker. And It will also publish the route extension proposal message to other services, and configurable delay and retry strategy will be also part of this service, background service. And the housekeeping service, it will be used for maintenance, like cleanup purposes. It will clean up periodically to maintain and clean up the route and request, and it will also get the value from the app setting intervals, and it will remove old or any expire request or routes, and it will run in background. It will be also a background service. So this is some information about the responsibilities of each background service. Now you can see here we have currently this is our project .NET 9, and currently we have two packages. One is the Open API, and the other one is the for containerization support. We added this. So now we will add some other library for encryption purpose. This will be part of this microservice. So first we added the EasyNet queue. Whenever we send or receive messages from RabbitMQ, it will do serialization, deserialization. For this purpose, we will use this library. And the third library will be the poly library for resilient try-catch. Our circuit breaker, we will use the poly library. So this one is added. So you can see here it's installed in our solution. Next, you can see here this is the route planning .http. So we will make some changes in this, like here we will use this to check the liveness of this route planning microservice. When anytime any service call this microservice, he will check. He can also check their health, it's available or not. So next we will add the domain layer, where the core business logic will exist in that layer according to the onion architecture. If you missed the previous session, so you can please check out the onion architecture session. So you will get what is onion architecture and how many layers is available in onion architecture. So the core of the onion architecture is the domain layer, where the business exists. So now in our route planning application, we will add the core, like the domain layer. So for this we will add one other class library. So I will give name, I will click on the solution, click on the add new project, search for class library. You can see a C# based class library, select and enter, give name route planning domain layer. This will be the name of our domain layer. So I'll click next, and the .NET 9 support. So you can see here layer is added. I will remove the extra class. So now this will be the main, the core of our route planning. So here we will add some models and business logic here. So let's add the model first. So first I will create one folder with name models, where we will add all the models related to the route planning, and then I will add one other folder called events, where we will define events in this folder, and the third one will be the tool, and third one will be the tool. So all the required folder is now added. So we'll add the related classes in event model and tools one by one. So let's add first the model. So here we will create some subfolder to separate each related to group each related model. So for this I will create other subfolders, like for the basic type I will create one other folder, basic type. Then there will be a queue output for input messages. I will add one, I will add to inside the model, and there will be a request related model I will keep in this folder, and the route model will be inside this route model. So this is like a separation of concern, so we can easily identify model for related to the request, route, and the basic type. So now I will add the models related to the basic type. So some basic type will require, for example, route status, to check the status of the route. I will add the route. So this is the easy part. So I will add one by one. So this will show the status like open, close, and aborted. So this will be the three status. And then I will add interval time intervals. So for this we have a start and end time. It will group the time interval for us, and the town basic information I will add one other type, town basic information, and this will be the properties. This is a C# class having ID, name and location. Here you can see pointer is coming from the system.drain, but for this I will add one other library. I will not use this one, the system one. So I will use the .NET topology suite. So for this I will go to the route planning domain layer project. You can add the library here. You can also click and go to the NuGet package, and here I will search for browse and search for .NET topology suite. So you can see here .NET topology. So I will add this library. I will use this for to get the geometrical representation, like for example the pointer. So I will install this. Okay, let's apply, accept. Okay, this one is install. One other library I will need. So the dependency injection abstraction, I will add this one as well. Okay, this two library is now installed. You can see here extension, dependency injection, abstraction, and the other one is the topology for the geometrical representation. Now you can see here dot drawing. I will remove this, and I will get this from the recent. You can see .NET topology, so I will get this from this. So you can see here this one is done. Now the pointer will come from the .NET topology suite. So next I will add one other object, one other class, user basic information, where we will this will hold all the some basic info, for example the ID and the display name. Just for now we can you can add other information as well. So this one, the basic type is done. Now I will add some classes to the output queues. So first I will add one repository related to the task and confirm new. So this will handle by this queue output message. So here I will add one class. This will I will show the interface. This will be the interface for the repository. So now I will add this. Yes, so I will add this letter, the repository, and a queue item, and we will add this letter. And now I will add the state object to the queue that will show the state. Now this will again be the interface. It will have some properties like ID, message code, and message content. And the other one is the item, queue item, and I will. Okay, so you can see here this will be the queue item. Okay, so we will add this letter. It will come from other basic type. So now this is yes, you can see here the repository will be added later. So this is done. Next I will add the model related to the request. First I will add the repository interface inside the request. It will hold all the business related to the request. So again it will be a request, I route request repository. And this will have some interfaces functionality, like for example it will have one aggregate. Aggregate is like a group of related entity, and this will be an aggregate for other model, for example basic town, and this will be the aggregate for the other models. And then I will add the route status. I request route status, and last I will add repository is added. Now state is also added. Now I will add the aggregate. If you want to know more about aggregate domain driven design, so you can check the previous session. You will find enough, but for now our focus is to practically do the route planning. So this is the aggregate. Okay, so this is done. Now I will shift to the route. I will add first a repository for route. So for this microservice, we are following the domain driven design and event driven design. So Again, if you have no knowledge about domain-driven design, so you can check the previous session. I already done a session on this topic, so you can find out the domain-driven design. So this is the repository, and also we are using the repository pattern and onion inside onion architecture. Okay, so this is done. Route interface repository is added. Now I will add the state. Okay, so this is done. We added the route related repository state and the aggregate related to the route request and the in output queue, and I also added the basic type. One other thing, I will add now the tools that is needed for the above. For example, the entity we need, and some other stuff which is missing, so it will come from the tool. So now I will go to the tool. First of all, I will add the entity class. Here this will be the entity, and this will be the information inside the abstract entity class. Okay, so we will add this later in the same tool folder. Now I will add some other concurrency exception related object. This will be the main repository interface for other repositories. For example, if I go to the iRoute repository, so it will inherit from this repository. It will come from the tool. So now you can see here. Okay, so now next I will add a unit of work. Again, a unit of work is also defined in the previous session, so you can find out some basic information related to the unit of work, its role in the DDD, so you can also find out this in the previous section. You can also copy the onion architecture from the previous session, like the onion architecture. I did a specific session about the onion architecture, so you can copy the code from that session as well. So this is again the unit of work. Now, so let's build some build issues. I will use the tool one, and again this is the build issues. Okay, this will come from the tool I did, and this is entity will come from the tool as well. Okay, let's add this class as well. Okay, so I will add this class outside all the folders. Okay, so you can see here it will be at the root level of this project. So I will add this class geometry constant, and currently there will be one static property inside this which is a default SRD. Okay, so let's build again. Okay, it will be interface. Okay, it will be interface, and it will be public interface. Build some other issue. Now this is gone, this is gone. Tool, add the package. We will add this later, attachment. Okay, no, so we will add this missing thing like attachment event, release event. So the event is missing, so what we will do, like we will add some events in the events folder. So let's add this event. So first of all, I will add the attachment event, request attachment event. So I will add one class name attachment request event, put this code. To make this video short, I just copy the code from other solutions, so you will get just idea how the microservices will be built. So it will save all time. This will be the match candidate event. So for this I will add this record and the release request event, released request event. Okay, so now this one is added. Now let's build. Now I will import this from the events folder, and this one is not yet added, and it will come from the system.data. So this is done. Okay, so now you can see here, now the domain layer is successfully completed. We added the events, attached request event, match candidate event, and release request event. We will use this in our other layer. It will used by other layers. So you can see here, this is the basic type. We added the basic, then output queues, messages, and the two main things, which is the route. Route will be offered by the driver, and the request, the passenger will create the request. So this will be the to handle the request, we add this, and some other common information we keep in the tools folder, like unit of work, events, and the repository. And this is for the geometric constant. So this is done for the domain layer. Now after adding the route planning, the web API project, then we added the domain layer, the main business layer of the application. And after that we add the shared messages, like which is the contract, basically the contract for route and vehicle tracking, and some basic types. Now next we will add another layer, another class library, like the DB driver, that will act like data access layer, and we will use this for entity framework. We'll use entity framework in this layer that will store the data inside database, and whenever we need any data, we can also pull the data from a database layer, from the database as well. So for this I will go with another layer. So I will click on solution, right click on solution, a new project, and again class library. Next, give name, route planning, microservice name, and DB driver will be a DB driver for our project. Next, and I will remove this default class. So now this will be the DB driver for our project. So to this we will add some entities, basically the data, the persistent data that will store in the database. So it will have some entities. So route planning will have some entities. So we will store in this, we will save this in entity folder I created. We will add some basic entities, like for example, for outbox queue messages, I will use this class, this entity, and this will be the there will be some basic field like ID, message code, message count, and ready message. So this will be the information we will store inside queue output item. After that I will add one other entity for route offering, like the driver will offer the routes. So to store it I will create one entity, a route offer, and there will be some basic entities, a basic field, like for example ID, line, string, and time, basic user info, the value entity, value object. This will be the value object, and this is route status, collection of route request, and the time span. And after that I will add one other route request. This is the route offer. Then I will add one other one for the request, route request, and here we will have some fields for this ID, town basic info, and town basic info for destination, and start, end, and some other route related route for route offers. So this is it. After that, what I will do, I will add a repository for this each entity will have in domain-driven design and repository pattern. Each entity will have their own repository. So for this, I will create one repository folder that will hold all the repositories for the route planning microservice. So first of all, I will add repository for the output queues item. So I will add this, and it will inherit from the I repository we define in the business layer. So you can see here, this is the I unit. It will come from the from this layer. In this layer, if we go to the tool, you can see here we have I unit of work basically. So this means that the DB driver will have access to the domain layer. So for this, I will add the project reference like the domain layer. So it will use the domain layer unit of work interface. So now you can see here, when I go to the repository, I will import the using. You can see here now it's showing the tool folder for us. So this is about I will also use the repositories as well, repository interfaces. In the, you can see in domain layer we have model output queues, and there is interface for this. So you can see here this is the interface. And okay, so we will fix the build issue because we don't have the context yet. So we will add the context and the other repository for each entity. So next I will add the route offer. For this I will add the repository, the related repository. Okay, so let's go and add the repository, the class for this, and here it will be the detail of the repository, the actual repository. Okay, so now this is added. And next one other repository for route request. So for route request I will add one other repository. Okay, okay, so this is added. Now let's save, and next I will add the mandb context. You can see here the mandb context is missing, and I will add this at the root level of this layer, the DB layer. So what I will do, I will close this, and I will right click and add class. This will be the mandb context for our route planning. So here I will do some I will import this from the DB context first. You can see here I will import from the DB, and you can see here it's giving me a compile time error. So for this I will add few like packages, EF core packages. You can see here there is nothing, it's not referencing to the EF core. So I will add some like packages for entity framework. So what you can do, you can directly add to this file, as well as you can also add this from the NuGet package as well. Okay, so to save the time, I will directly paste like I will need the EF core SQL Server, because we will save the data inside SQL Server. You can use any other database as well, like Postgres and any database, relational database of your choice. And the second thing is the .NET topology suite. This is for the geometrical representation, and the third one will be the EF core tool to like build and run migration, update database, something like to run this command. So now the packages part is done. Okay, so now you can see the package is also added, and if I go to the project, you can see here this is the project domain layer is referenced in this DB driver. So the key principle of the clean architecture, onion architecture, is that the domain layer, this is the domain layer, it will have no reference to the other project. So you can see here it's independent, and this one, the DB driver, is accessing the domain layer. And you can see here now I will add the from the queue state, and I will fix the build issues. It will come from the .NET topology suite, like geometrical representation. I will add this reference, and this will be the part of the basic type from the domain layer. And you can see here now this is working. I will add the interface from the domain layer. So this is done. Next I will go to this. Okay, so route object is also route request is also done, and now I will go to the repository, and I will fix the repositories. If I go to the main context, I will add the package, EF core package, and the unit of work will come from the interfaces unit of work. Okay, so next, this is not implemented yet, so I will implement this by adding the required code to this. I will register each entity in this main DB context. As you can see here, I added the request route entity, route offer, and output. This is the three entity. We will save data related to this in the SQL Server, and this is the model builder. Like you can configure each property here in this method on model creating. Whenever the model is created, this rule will be applied. And this is some basic save entity, unit of work related methods, and you can add the missing references. So now unit of work is done. Next I will add one factory, like DB factory. So for this I will add one other class at the root level. So add class and give name library design time DB context factory. So it will build the DB context at runtime. So it will have the connection string and the other DB context related option. So for this I will add the code related to this repository library factory. So you can see here it's implementing the design time DB context factory. I'm passing the DB or main DB context, and this will be the connection string to my local SQL server. You can install any other server as well. So like Postgres. For now, for this course, I will use the SQL server, and it's a build taking argument, and it's build use the connection string, basically creating the builder for us. So this is done. What left, whenever we run a migration, it will create the migration file, migration folder, and migration related file as well. So next, the final thing, we will add one extension to like this layer will be registered in our API layer, this one. So for this, to store this, to connect this to our routing planning web layer, we will add some extension. So for this I will add the extension folder where I will keep all the extension. Add folder extension though. So the first extension I will add for the DB, I will add the DB extension where we will reference this in our program.cs in our API layer. You can see here where we will reference this extension in this file. So for this I will add one static class DB extension where we will have one extension method. You can see here extension method that will return the iService collection, and it will take iServices and the connection string. So add the required packages. Okay, so next I will add another extension that will be used for the repository extension repositories. It will be a repository extension. Okay, so this is the repository extension. Add all repository. It will register all the repositories we have in this layer in our API layer. Okay, so it will scan for each for the whole assembly, and if they find anything inherit from the I repository, they will take it and they will register in our program.cs, and it will register as a scoped. Okay, so this is done. One will be the interface and the other one will be the actual repository. So this is done. Okay, so after adding the DB driver layer, next we will add the final layer, which is the application service layer. Again, it will be another class library, and I will give name a route planning application service that will have all the command and queries. Okay, so next .NET 9 support, remove the extra class. Okay, so now it's the application layer is now created. So first I will add the required dependencies and the projects that needed to this application service. So for this project, I will need some two extension, Microsoft extension method. You can see here, I will need extension configuration abstraction and the configuration builder. And the other thing, we will add the references to other some two other project as well. I will add one new project reference, and it will be a domain layer. So our application layer will use the domain layer because it's a onion architecture, and the dependency will come from the domain, then application layer, then presentation layer. So and the other thing, I will add the messages because in shared messages we have contracts, so the queries and the command handler will use those contracts. So I will add these two project in our application service. So now this is added. Next I will add one folder that will be a command handler. I will click add a new folder, command handler, and it will have all the commands. For example, message related command handler, I will create some extra one subfolder, messages, that will hold all the messages related command handlers. For example, for now, if I go to add one command handler for the request, I will add class and route request message handler. So this will be the request message handler. Okay, so after that there will be commands, because it will trigger the command handlers. Command handler will trigger the commands. So I will need a command folder. So I will add one other folder, commands, and inside these we will have commands. And for now I will add one command, class message command, and it will be of type record. Okay, so it will be of type record. So we will fix this compile time error when we complete this application service layer. And after that I will add one other folder for event handlers that will have all the events, event handler. Okay, so I will create folder. Okay, so there will be different event handlers. For example, attach event handler is one event handler for this, attach event handler, and I will add code related to this handler. It will use the iRoute request repository, and it will inherit from the iEvent handler. And okay, so next I will add the offer match candidate handler, offer match candidate handler. Okay, it will prepare the message by taking the route request aggregator, and it will set the destination. We are setting the destination resource, and we have the handler. This is the handler. It will take the configuration value from the app setting. We will add values, configuration value to the app setting later. And next I will add the release event handler, a release event handler. Okay, release event handler is done. Now I will add the candidate event handler, match candidate event handler. Okay, so this is done. Let's also add the other command as well. So to complete the application service, I will add the housekeeping, as we discussed that we will have three services. One for housekeeping, and the housekeeping command will have one record, and the other one will be the messages, and third one will be the output sending command. Output sending command. Okay, so output sending command. Okay, so next I will add the other messages related event. So I will add the route closing, and route closing will take the route of a repository, and it will also have the unit of work as well. If unit of work is the part of the domain layer, you can say here this is the unit of work. We have the save changes and start, commit, and rollback. So the implementation of this is located in the DB driver class. You can see here when I open the DB context, you can see here this is the implementation. We implemented the save entities async, and this is the start that will begin the transaction, and it will commit the transaction, and it will, if anything wrong happens, then the rollback will happen. So this is about the unit of work. Okay, so this is done. The close message handler is also done, and now I will add the extended message handler. Okay, so this is also added. Again, it will handle the request. It will call the handle async, and it will start the unit of work, and it will get the route by ID, and it will do the other operation. And next, the final will be the offer message handler. Offer message handler. Okay, offer message handler is also added. So now we have repositories, unit of work, and event mediator. So event mediator and some other stuff is missing. So for this we will create one other, like a folder, and we will give name to this folder, tools folder, and we will keep like the things like event mediator, iCommand, iQuery, something like that. So let's add this one by one. Okay, so let's close the other. Okay, the first thing I will add to the tool is the mediator. I will add the mediator that will trigger the event handler. Okay, so this is the definition. It will we have one read-only iService provider. It will inject the iService provider, and there is one method. It will trigger the event. Okay, so next is the event trigger. Event trigger is missing, so we will add the event trigger. Event trigger is added. Okay, so it will inherit from the iEvent notification, and you can see it will have two methods. One method which is the trigger. It will trigger the event, and some other iEvent handler is the next thing. So I will add event handler. iEvent handler is added, and okay, this iEvent handler. And next thing, I will import. Okay, so this one is added. This one is also added. Now some other command, I command and I command handler also needed, and query as well. So I will add the I command. If I go to the command handler, you can see here I command handler is missing. So I will add the command I command and I query. So let's add I command, and it will be interface, and the other thing is the command handler that will implement this. Okay, command, and it implement the I command handler. Okay, so we have one generic and the other one is the simple one. And now the next is the iQuery. The last thing is the iQuery. Let's set iQuery, and it will simply public interface. Okay, so this is done. So now a messages part is done, and one other handler is missing for housekeeping and output sending commands. So if I go to the handler, we added the messages, but for housekeeping it's missing. So I will add the housekeeping handler as well. It will remove the request and response from the database for cleanup purposes. So okay, so now it will take delete the offer and the request, and the other thing is the output sending request handler, command handler. Okay, so this is command handler. Okay, so let's build. And for extension, like to register this into our program, that's yes, in our API. So we will add one extension folder that will hold all the extensions, and there will one extension for now, which is the handler dependency injection extensions, and we will scan for the repositories, for the handlers, and it will register in our program.cs class. So this is done. So now we will focus on the web API project. We created initially the domain layer. We defined the entities and aggregates and events and value object, and after that we defined the contracts between the microservices. Will communicate with this messages contract, and then we added the DB driver. We use the entity framework core as a data access layer. It will save and retrieve data from database, and we define the DB context. We have, if we go to the DB context, we have three models: route request, route offer, and output queue types. And then we created the actual like the application layer. Application layer have command handler, commands, events, and you can see here we created the different type of events that will be triggered, and this is the housekeeping event handler. If I go to this one is the for the housekeeping cleanup type of thing. It will use the request repository and offer repository. It will do the cleanup, and after that we will register this in our program.cs. This is the web API layer. You can see here, first of all, we are using the open API specification. Then we are going to register the application service. As I already mentioned that inside application layer we have extension. You can see this is the extension. It will inject, it will connect basically the application layer to the inside the API layer. So you can see here, this is the extension, and we are injecting, we are adding this service in this part, program.cs. And the other thing is the DB driver. If we go to the DB driver layer, this is the DB driver layer. It's accepting the few things like services and the connection string, and we are injecting this from the entry point of our application, like the API layer, the routing planning. You can see here we are passing the connection string, and we are defining this in our app setting. If you go to the app setting development JSON, you can see here it's the connection string of our local database. Okay, and then we have RabbitMQ. We will discuss this later. So after that we have RabbitMQ connection, and this will come from the connection string as well. So once we run the Docker container in our Docker Hub, so it will host on the localhost 5672 port, and we can access in our application. And after that we are adding the hosted services, like we have three services, like man service that will act as a subscriber. Like it will create the exchange, it will create the quiz, and it will also handle the serialization, deserialization with the help of this easy.NET Q library. And yes, so here we define the service, and we are registering this in this part. And we are using in development mode, and here is one endpoint, liveliness. We will check the health of our service or background services. So now we will run the RabbitMQ for communication purpose, like as a message broker locally in Docker Hub. We will need to install the Docker Hub in your system. So first of all, if you don't have a Docker Hub installed, so please install. And you can see here we have no container yet. And if I go to the images, this is all the images we have. Some of the images is needed for Kubernetes, so this is complete. You can ignore this completely, and you can see here this is no container. So what I will do, you will open the command prompt, and you will write one command to get the image of the RabbitMQ. So you can see here this is the Docker run, and this is the name of the it will be the name of the image container, and it will run on this port. And we are giving the password, username and password, like the admin will be the username, and also the admin will be the password. And this will be the default host slash, this is the default port. And if you run this, it will you can see here the image is not found. So first of all, it will get the image from the repository. Once it's download the image, then it will run the RabbitMQ container. So let's wait for this. Okay, so image is downloaded, and this is the status. If you go to the image, it will show the image for you. You can see here it's the tag number 4.0 management, the tag number, and you can also change the tag number according to your need. You can see here this is the tag number, so you can it's up to you. And again, this is the image ID, and this is all about the images. Once you get the image, you can say this is the container. If you click on this container, it will show the log, inspect, and the other files and stat. And here is the ports. It's running on the localhost 15672, and this is the other port. So you will click on you can click on any of these URL. So I will go with this. Once you click, you will get something like this. It will show you the overview. And it's a connection. Currently there is no connection. This is the channel, and this is the exchanges, and this is the queue and a stream. So now you can see here the RabbitMQ is up and running. And let's go back to the code. You can see here the connection. They will get the RabbitMQ, and after that let's go to the main service. You can see here this is the main service. It will publish send message to the exchange. When I run this microservice, this main background service, it will send the it will create the exchange for us. You can see here it will create different exchanges, one for the route offer, and the other one for close route abort message. The other one will be for extended route, and one for the so it will create different exchanges for us. And this is the API needed for route request messages to handle for now we will publish the message from the dashboard directly, so it will trigger. So once you run this application, our container is already running, and before this you will run the update database command. You will open the updated the command prompt. You can see here this is the NuGet package manager. You will open the command prompt, or you can also use the PowerShell and you will run the command like for update database. So you can also use the PowerShell as well. PowerShell, you will open the PowerShell and you will write this command like .NET EF database update. Once you run this application, it will directly create the database to your local storage. For example, if I go to the database, you can see this is a car sharing, and this is the table we define in the DB context. And you will also find out the if you go to the driver, the DB driver, you can see the DB driver. We have the first you will run the migration command, EF core migration command. Once you create if you don't have the initial migration, so first you will run the migration command. I already run the command, so I got the migration and the file. Once you will find this code as it is, so you don't need to run the migration command. I already run the migration command. You will need just to run this EF core update database command. Once you run, you will find out the related database in your SQL server. Okay, so let's go back to the hosted service, main service. We will discuss the housekeeping service and output sending later. So this is done. So let's run the application. So you can see here the application is successfully running, and it's running. And let's test this by sending one message from the RabbitMQ. If I go to the Rabbit, you can see here now when you open the connection, you will find out two connections. Connection number is 2, and it's from one is from planning, both is from route planning, and this is the protocol we are using, and it's running. And this is the channels, and this is the exchanges. So you can see here the main, if you go to the main service, if you open the main service, so it will create the exchanges SQ for you can see for the request offer and close, extended. So we will find the same thing here in exchanges. So we have these exchanges. One is for the vehicle tracking and tracking messages, vehicle tracking messages. The other one is for route request message, offer message, extended, and close abort message. So exchanges is created, and queue is also created for this. Now if I go to the exchange and try to create one route request message, I will open this exchange, and you will go to the publish message section. This is the publish message section. So now I will add the header, and this is the type. We will use the same contract, and this will be the payload for the message. So you can see here we are defining the source, and we are destination, when to start. This is the user ID. This is just a test message. Okay, so when I publish, you can see the message is published, and if I go to the result, you can see here received route request JSON. So they are processing the passenger information, and they are successfully serializing. And you can see here if I go to the queue, and this is the respective queue for the route request message. So you can see here it is they are processing the message. And if I go to the database, here is the request. So you can see here this is the request. So this is about how the RabbitMQ communication will work. So now we'll test one route offer message as well. So you will open the specific route offer message exchange. You can see here you will go to the publish message. So I already created one JSON for this. So this is the JSON, New York, like longitude, latitude, and here is like the when to this is the when, and this is the user, and this is the driver information. John is the driver. So once I publish, you can see this is published, and when I go to the queue, you can see here this is the attached queue to the exchange. So you can see here this is the exchange for it, and it will handle the offer. And if I go to the log of the file, log of the application, you can see here this is the message coming from the driver side for the offer. You can see here this is the offer. And you can also check in the table, the offer table as well. You will select, you can see here this is the offer, this is the path, information path, this is the when, the time, and this is the driver and information user ID, and this is the status. So I show the request and offer practically how it will be handled by using the RabbitMQ. Let's discuss some basic of the message broker as we are using a RabbitMQ. So if you are new to RabbitMQ, so this will be the basic information related to the RabbitMQ. So RabbitMQ is nothing but a message broker, robust message broker actually. It supports the AMQP protocol, and it offers a lot of tools like for scalability, redundancy, and disaster recovery. And for a message format, as we already saw in the practical microservices, routing microservices, we saw that we install the easy netqueue library for messaging, like it decrypt serialized, deserialized messages. And as you can see here in the RabbitMQ, this is we have two connections, and the protocol it's using the AMQP. So it's using the AMQ protocol according to this RabbitMQ is robust message broker that natively support the AMQP protocol. And you can see here there is two concepts, one is queue and exchange. As you can see here, we have exchanges. Whenever I run the application or API application, the routing microservice, this exchange is created. So this is the exchanges and this is the queues, and each exchange, if you open, for example, it's a route request message, okay. And as you can see here, this exchange is bind with this queue. So this is the queue, this is the binding between the exchanges and the queue. If you click, it will redirect you to the queue. So let's back to the slide. Queue where messages are stored. So what is queue? Actually, the messages is stored in the queue. And what is exchange? Route messages to one or more queue based on their type, okay. So each queue have their own type, and exchange are an AMPQ concept that help implement complex communication protocol. So as you can see here, this is the exchange, and this is the type. We will also discuss the exchange type. This is the exchange type, direct, topic, and fan out. So, and the other one is the header, and this is the queue. You can see here, this is the type of the queue. This is the classic. We are using classic queue type. So I hope you will understand, like queue where messages are stored, queue messages are stored in the queue, and the exchange basically route messages to one or more queue based on their type. And so this is the diagram. Messages come to the exchange, and exchange further redirect the message to the queue based on their type. And basically you can see here the basic functionality of the exchange is the routing. They have the routing strategy. And this is the type of exchange. We have default exchange, fan out, and topic. As you can see here, when I go to the exchange, we have topic, and we have default. Default is not there, and we have a topic exchange. Topic is there. So default exchange send message to a single queue, enable our direct asynchronous call pattern. And about the fan out, send message to all queue, all the subscriber queue, and enable publisher subscriber pattern. So this is the main difference. Default exchange work on based on the asynchronous call pattern, and in the case of fan out, they have publisher subscriber pattern. So you can see here, this is the fan out, this is the default. When you run the RabbitMQ container, it will create in default. So this is our own. This for 1 2 3 4 5. This 5 is our own created exchanges. And topic, what is topic? And all of our exchanges is of topic. So what is topic? An advanced fan out exchange that allow for message filter based on named topic. So we have it work on the based on the named topic. Welcome back to Practical Serverless and Microservices with C#. My name is Muhammad Abdullah, and I am a Microsoft certified Azure solution architect. In this session, we will discuss Kubernetes, but this session will contain different parts. So in this first part, we will see the orchestrator. What is orchestrator? We will understand their services, and we will also understand the YAML. So YAML is the basic thing to work with Kubernetes or orchestrator. So if you want to understand the files that is needed for Kubernetes, so you should know about the YAML syntax, how to write the YAML file, and their rules and regulations. So for this part, we have this learning agenda to understand the orchestrator, what is orchestrator, and why they need it, and their fundamental services, and the basic sentence of YAML is orchestrator. So orchestrator are system designed to manage and coordinate containerized application across multiple servers. So in microservices, we have different containerized application, and one server have different containers. So orchestrator is needed to manage those containers across different servers. So orchestrator provide you load balancing and between the different microservices replica, and orchestrator also automatically scale up and scale down. And the third point is service discovery and networking. So this is the main feature of orchestrator. So whenever orchestrator come in your mind, you can think about the Kubernetes. Like Kubernetes is orchestrator. So Kubernetes is nothing but orchestrator that do the load balancing, auto scaling, and service discovery and networking, and also provide you the health monitoring. You can check health of different microservices, and based on that you can take any decision. And the fifth point is they also provide you storage. So this is the main benefit of using Kubernetes or orchestrator. So question, why we need orchestrator? So if you don't use orchestrator or Kubernetes, so you will do this thing manually. For example, decide where to place each container replica. You will do this manually. You will handle the load balancing manually between the replicas, and monitor container health. You will do this thing manually, and whenever any container fail, so you will start it manually, and manage network communication between the services, and storage allocation. So this is all the thing which you will do manually if you don't use the orchestrator. So using orchestrator, this thing you can automate with Kubernetes or orchestrator. So the next thing is YAML. So what is YAML? It's a human readable file that work with Kubernetes or orchestrator. It commonly used for configuring file and exchange data. So this will be the definition of the container. So now we'll see one example. So I will go to the VS Code. So I just open the VS Code. There is nothing but empty project. So first thing we will discuss, I will show you one JSON file. Okay, so JSON file with person definition. For example, I will create one JSON file, person.json, and this will be the definition of this JSON file. So you can see here, this is you already familiar with this JSON file. It's well known. So you can see here its name. The name is John, surname health, and it's basically a key value combination. And here is the list. You can see here you can add also a list. And another property is related to the addresses. This is the array that have two addresses, type home, and the other item is of type office. So this is one example. So I will show you the alternate of this JSON file, which will be the YAML file, person YAML file. So first I will add one person YAML. You can see here you will write this extension YAML. Okay, and I will show the exact key value pair, but in a YAML file. You can see here it's the same JSON file, but it's a YAML. So this is the, again, it's a key value pairs. So this is the key, this is the value, surname Smith, this is the spouse, and this is the name Mary, surname Smith, and this is the address. So this is basically a definition of YAML file. Okay, so to write this file you will follow some rules. Okay, so the first rule, you will not use a tab, but you will use space. For example, between this key value pair I am using not the tab. If you use tab, it will be a mistake. So what you will use? You will use spaces. Okay, so this is the first rule. The second rule is, you can see this is a hyphen, so it represent a list item. So this hyphen, you can say this is a hyphen. You can also add one another item, go back, and you can say here this is another item. Okay, so what does this represent? It represent a list. Okay, so this is the list, and this is the second rule. And the third rule is for this column. You can see here, this is the column, this is the column. So after this column, you will give one space. If you do like this, for example, street, and without if there is no space, it will be a mistake. Okay, so after this column, you will use a space. So this is a rule. And the other rule regulation is that for comment, you can use this hash. So if I write any comment, you can say this is a comment, another comment. So this is the other syntax rule. And okay, so this is the basic rules for writing a JSON file. So next I will show you one other JSON file with two spaces for consistency purpose. So you can follow the same rule for when you write the YAML file. So I will write person2 YAML. Okay, so you can see here I added one other file, or I can also name some other service, user service. For example, this is my app name. So I give user service, and this is the definition of this YAML file. So you can see here, this is the API version, it's v1. This is the upload. We will discuss different type of services. It's upload type, and it's a meta, and it's a list, and it's a name and a label and specification. So this is the a good consistent indentation with two spaces. So another point is that you can also do the inline syntax. You can also use the inline syntax as well. Okay, so what if I add other user service inline inline.yaml. Okay, so this will be the inline. So you can see here it's a inline. So there is a difference. For example, if you see the meta, it show my prod and label. So in this case, you can see here it's a label, and that it has a app and version. So it's the example of the inline syntax. You can also move this to this file as well. You can see here. Okay, so this is the alternate approach of this. You can write this way as well, and you can also follow the inline as well. So this is the two example. And the other point is that now I will write one complete example that will show a person information. So I will create one other complete person profile, for example, YAML. Okay, person profile YAML. So what I will add some basic information related to the person, and some their skills, and some other information like what project they completed, something like that, just to show you how you can write the YAML file. So you can see here this is a person, and its name, age, and is different properties, and it's a contact information. This is the contact information, their skills, and it's the project information. So this is one example. Okay, so next you can also convert, like if you have a JSON file, you can also convert that to the YAML file as well. You have also YAML. And okay, so one other point, that you can also define multi-document YAML file. So what is the multi-document YAML file? So I will add another multi-doc. Okay, so multi-doc document. So first I will add one document, the first document. So you can say application configuration version 1 config map. So this is the database data related URL. So the other document, for other document I will use this. So for example, this is the multi-doc YAML file. So this is the second document, again version, same kinda information, metadata, and I will this is the document YAML file. So you can also define different document in a single YAML file. Okay, so Okay, so this is all about the YAML file. So again, if you there is some few mistake, if you don't give any space, it will give you error. And I will tell you one other. I will show you one other application. So you can see here, this will you can use this application. You can paste your YAML, and when you click go, it will correct your YAML file. It will show you the invalid data, invalid character in your YAML file. So for example, if I have this YAML file, you will paste. If I don't, okay, so you can say I remove the space and it show the error. A key needed to be single line at line 2 end. So you can use this application. You can also use the another application, online parser fspot.com. So you can also use this one as well. So this is the mistake many people make. So okay. Okay, again, if you make any spelling mistake, they will also not compile. So if you make any spelling mistake, this will be another issue for you. So the spelling mistake, they also check for the spelling mistake as well. So this is all about the YAML. So this is done. Okay, so next in the next part, we will discuss Minikube. For local Kubernetes development, we will learn basic Kubernetes commands, and we will write first Kubernetes pod and explore the Kubernetes cluster in architecture. So this is all about the part 1. See you in the next part. Hello everyone, welcome back to Practical Serverless and Microservices with C#. My name is Mohammed Abdullah and I'm Microsoft Certified Azure Solution Architect. This is session number 10 and we are covering Kubernetes, and this is the part number 2. In this part number 2, we will discuss Kubernetes basics, and we will set up a cluster. If you missed the first part of the Kubernetes session, so please check out the first session, then continue this part number 2. Okay, so learning objective for this part, you will understand the Kubernetes, their architecture, the core component, and after that we will install the Minikube for Kubernetes local development, and we will use the kubectl to interact with Kubernetes cluster, and we will try to understand nodes, master node, and cluster concepts, and perform basic cluster operation and troubleshooting. So we will cover this 5 things in this part. So for this part number 2, please check out the first part where I show the YAML fundamentals. So for this part, it is prerequisite to watch the part number 1, and you should also install the Docker desktop, and you will also need administrative access to install softwares. So this is the prerequisites. Now, what is Kubernetes? So like the orchestrator, Kubernetes is a distributed orchestration system that manages containerized application across multiple machine node. So same thing like orchestrator. Orchestrator also manage containerized application across different server or node. So behind the scene of the Kubernetes, there is an orchestrator. So Kubernetes is nothing but orchestrator. Okay, so Kubernetes have different component like API server, and that is the central management point that handle the REST operation. Here is the diagram. You can see here at the top we have a master node that have 3 component. The first one is the API server, which is the central management point, handle all the REST operation. And the second one is the scheduler. Scheduler decide which node should run each port, and the other one is the controller manager, monitor cluster state and make correction. So this is the 3 main component of the master node. So apart from that, we have the etcd, which is the key value storage for cluster data. So next is the worker node. Below we have a worker node, and the worker node have 3 components, which the first one is the kubectl, and that is the agent that communicate with master and manage your container, and the other part is the container runtime that provide runtime to the container, and the third component is the kube proxy, handle network routing and load balancing. So kube proxy is responsible for the routing and load balancing. So I have one diagram, so I want to show. You can see here, this is the one diagram for the byte by go So I just copy this diagram to explain. So we have a Kubernetes that run the application and bind the dependency. Then they provide Docker file. We write a Docker file and we build image from that Docker file. And once we have a image, then we run that image as a container. So you can see here, this is the part of the Kubernetes, and Kubernetes we have a master node. A master node have a API server and scheduler and controller manager, and worker node, we have a worker node that have a kubectl and container runtime. So this is some graphical representation of the Kubernetes. Okay, so okay, now Kubernetes have different type of resources. For example, we have a pod, which is the smallest deployment unit, and pod can have one or more containers. And the second is we have a server, provide stable network access to the prod, and the third one is the deployment, manage prod replica and updates, and the fourth one is the namespaces, a virtual cluster for resource isolation. So we will see all these pods, services, deployment and namespaces. We will create this practically. So next is so you will need to install the Minikube first, because we will use Minikube for local Kubernetes environment. And you will run this command choco install Minikube, and you can also install Minikube from this page as well. This is the official Minikube page. So this is the Minikube start. You have they provide Linux, Mac and Windows, and I have Windows, so I will run this command choco install. So if you, first you will install the Minikube. So first of all, you will open the command prompt as a administrator. So I will run this as an administrator. So you can see here, this is the command. You can use PowerShell or other terminal of your choice. So this is the choco install Minikube. So I already installed. So that's why it will give you this type of information. But if it's not installed, you can say it already said that already installed. So if you have not installed the Minikube, so you will run this command. So this is the first command, and after that you will install kubectl. Okay, kubectl is the primary tool for interacting with Kubernetes. So you will also need this command to run in your local system. So let me correct. Okay, so I will write this command choco install Kubernetes CLI. So it's I already installed, but I want to show the command which what command you will learn. So it's already installed. How I will verify kubectl version. If you want to check the version, you will run this command kubectl version client. So you can see here client version is v1.31.1 and customized version is v5.7.1. so this is the install version of the kubectl. So next we have some command like basic Minikube command. So you will learn this basic kubectl command. For example, if you want to start the Minikube with default setting, so you can run this Minikube start. And if you want to run the Minikube with specific configuration, so you can use the Minikube start CPU. You can mention CPU size, memory size and disk size. So this is the specific configuration. So when you run this command, it will create these resources for you. And if you want to run the Docker with if you want to run the Minikube with Docker, so you can run the last command Minikube start driver equal to Docker. So I will use this command because I already installed a Docker Hub, so it will be fine to run this command in my local system. So this is the other. If you want to check the status, you can write Minikube status. If you want to stop Minikube stop. Similarly, you can delete, pause, and unpause the Minikube. So let's check this command one by one. Okay, so you can see here. So first of all, I will try the last command, minikube. I will use the Docker one. I will write mini cube start driver equal to Docker. So I will run this command. Once you run this command, it will run the minikube. So I already have one instance, one cluster. For example, if I check status, it will show I already have one running instance. So if you can check the status, if there is no cluster, then you can run the minikube. So you can see here, when you write the minikube status, it will show the type, host, kubectl planning, API version, and kubectl config. So this is the first step. You will run the minikube, which is currently running in my local. So next point is that you can how you will check the cluster information. You can also check the running instance in Docker Hub as well. When you open the Docker Hub, you will see the container. You can see here this container is currently running in your local Docker. So it is currently running. So I will show some other cluster get nodes. So you can see here it will show all the node. Currently one node is running, and other command kubectl get all. It will give all the services. So with the type, cluster IP, and this is all the information about the node. And you can also get information about the namespaces. If you want to know about the namespaces, you can also get this information as well. So kubectl get all, and here you will mention all namespace, SPACES name. So you can see here, this is all the namespace information. So this is all the namespaces we have. So how you will work with the namespaces? So kubectl get name spaces. You can say here we have this namespaces: cube node, less, public, system, and dashboard. So we have this namespaces, and you can also create namespaces as well. For example, kubectl create namespace, and then you will give name to your namespace. So you can see here namespace is created. If you get again the namespaces, you can see here your namespace is created, my name. So this is how you will create. You can create your namespace, and you can also get the current context. So how you will get the current context? kubectl config current context. kubectl config, spelling mistake, kubectl current context. So this is the current context. We are working in the minikube context, and you can also view the kubectl configuration. So how you will kubectl then config view. So this is all the information regarding the config. So this is all about the namespaces. Next we will how you will explore your cluster. So there is few command we will explore those command. For example, if you want to check the cluster information, kubectl then cluster info. So here is the cluster information. Next if you want to list all the nodes, so kubectl ctl then get nodes dash o then wide. So it will give all the nodes. So you can see here minikube the status is ready, and this is all the information. Okay, so next we will you can I already show how you can create the namespace. You can get the namespaces, and so here we will discuss one thing about the context. What is context? So context is the combination of the cluster, user, and namespaces. So these three combine make the context. So this is about the cluster, Next, we will create first Kubernetes resource. So for this, I will go to the VS Code. So this is my VS Code. So here I will create one resource, my first resource, first Kubernetes resource. So how I will create? So first of all, I will create one file with this name, and that file will be the YAML. If you are new to YAML, you can check out the first part of Kubernetes, session 10. So this is the first port, and here is the definition of this file. So this is the definition of this file, API version 1. This is the port. I already discussed that Kubernetes have port, namespaces, and other resources. So this is the port resource, and port is the smallest deployable unit. Okay, so here is the metadata, hello world, namespace default. We are using the default namespace. Okay, and then we have a label, container information like container name, and this is the image, ingress image we are using, and this is the port number. So this is the first how you will create your first Kubernetes resource. And for this, how you will deploy and manage this pod. So for this, I will open the terminal. So this is my terminal, and here I will write my first command to deploy and manage this resource. So first of all, I will apply the configuration. So for this, I will run kubectl and apply f, and then first you will give name first name of the file. You can say first pod. So this is my file name and extension. So this will apply the configuration, kubectl apply f, and the name of your pod. So you can say here, it said that it is created. So this is the first thing, it is created. Okay, next we will check if there is any port running. So for this, I will run kubectl get port command, kubectl get ports. It will give all the port. You can say here, it's showing hello world, which I recently created. You can say here, this is the name. The name is the hello world, and it's currently showing us ready 0-1, and it is showing status. The container is created, but it's not running. So now how I will get the detailed information. So for this, you can use this command, kubectl describe pod, and hello port, name of the port, hello world. You can say here, we have one port with name hello world, and I am giving the same name to get the detailed information. So this is the detailed information of my port. So you can say here, this is the detailed information. It's showing reason, age, from, and the message. Okay, so after that you can also check the logs of your pod as well. So there is a command, kubectl get logs, logs, and the name of the pod, hello world. You can see here, this is all the logs showing. Okay, so let's check the okay, so this is all about the kubectl we created the first pod, and it's running. And you can also there is also a command to delete the pod, so you can also delete as well, kubectl delete pod, and name of the pod, hello world. So pod deleted. Now if you check the pods again, there is nothing because we deleted. And so this is all about the Kubernetes resources, how you can create the resources. Okay, so also we have you can also check the dashboard of the Minikube as well, Minikube dashboard. So you can see here when you run this command, it will display the dashboard. So welcome back to Practical Serverless and Microservices with C#. My name is Muhammad Abdullah and I'm Azure Certified Azure Solution Architect. This is session number 10 about Kubernetes, and this is the part number 3. In part number 3, we will see the pod and basic configuration. If you missed the part number 1 and 2 of session 10 Kubernetes, so please check out the first and second part. So for this, we will understand pod anatomy and their specification. We will create pod with multiple containers, and we will see how to implement init container and the sidecar pattern. And we will also see how you can configure environment variable and command override, and we will also see how you can share volume between different containers, and at the end we will see how you can debug and troubleshoot pod issues. So first of all, you will check out the first and second part of this series, and the other requirement you should be able to the Minikube should be running in your system, as well as the kubectl also configured and working. So these three is the requirement to continue this part. So first of all, we will understand what is pod, what is mean by pod in Kubernetes environment. So pod is the smallest deployment unit in Kubernetes that like share network APIs. If two containers share same API, same port, and share some storage, and lifestyle create destroy together, so this is called pod. So this is the definition of the pod, that when some container have share network storage and life cycle, like if there is two container that should be created at once or should created destroyed together, so this is called pod. This is the deployment unit in Kubernetes. So why we use multiple container in pod? When you have a side pattern, like a side pattern help container enhance main container, we will see this in action. For example, if one container try to log information, error messages or other information for the main container, so in this case we will implement the sidecar pattern. And the other one is the ambassador pattern, like it used for proxy container that handle external connections. And the third one is the adapter container transfer data from main container to another container. So this is some three pattern we can use in Kubernetes. Okay, so now I will move to VS Code, and I will show you the basic pod XAML structure. So let's go to the VS Code. So the first requirement is that the Minikube should running in your local system. So I will verify Minikube status. So this is the command where you can use to check the status of the Minikube. So you can see here it's currently up and running, and you can also check the kubectl as well. So kubectl is also installed and currently configured. So this is the two requirement before start. So now I will show you the basic pod XAML structure. So for this I will create one XAML file. I will give name basic pod.yaml. Okay, so this is the basic pod YAML. So this will be the basic pod for. Okay, so you can see here we have this is the basic information about the pod. Kind is pod, metadata information, and this is the container specification. This is the restart policy. You can use always, on failure, and never. Whenever any container fail, you can restart the container by giving this option, by using this option. And this is the image name, so it will pull the image from any image registry. And if you have any init container that will run before the main container, so you can also define. And this is the volume. If two containers share same volume, same storage, so this is called pod. So they have some main volume storage as well. So this is the basic version of the pod. So next we'll see pod with environment variable. So how it will look like, I will create simple pod env. So env mean environment variable. Oh, this is the extension. So this is the simple pod with environment variable. So this will be the definition of the simple pod. Okay, so you can see here, I will change the name to simple pod. I will remove the env. Okay, so this is the pod, and this is the definition, definition, API version, basic definition, and this is the container specification. So there is one container, and it will take image from Elfin latest, Linux Elfin latest, and they will use this bash command, and this is the argument list. Okay, echo, it will write this message for us, hello from my name, and this will show a dep after 5 seconds. It will print this message, and this is the variable. So the main thing is here is that I am passing environment variable. So this is the list of the environment variable I am passing. So the first variable is the static variable, hard-coded variable. So this one is the hard-coded variable, and this environment list have three items. One, and this is mine, for one for name, the other one for namespace, and the third one for the port name. So the first one is the hard-coded, and the second one is used for namespace, and you can see here I'm using value from and reference, field reference. So it means that the Kubernetes automatically inject value from pod owner metadata when the pod start. When pod start, Kubernetes automatically assign name for this, the default namespace, okay, on which the pod is running. And the third point, the third variable is same, similarly it will be automatically assigned, and this will be the pod name. So this is how you can define a pod with environment variable. Some is the hard-coded, and the other variable is from automatically assigned, Kubernetes automatically assigned. So we will first deploy this. We will apply, we will run this command kubectl apply, and this will create the pod, and once it's created, we can run another command to check the pod, kubectl get pods. So you can see here one pod is running, currently in running state, and this is the name env pod. Okay, and next is you can also view the log as well. You can check the log as well. So I will run kubectl get log. This is the log. You can see here it will log the it's logging the information. Hello, this is a message, and this is the date. Okay, if you want real-time log, so you can use this this command as well, kubectl and again logs, and fenv port name. So this will be the port name. So it will show you a real-time log. So you can see here it's printing the message. Okay, this is all about the simple pod with environment variable. Okay, so next the final step, I will clean up this pod for the next example. So this is deleted from the default namespace. Okay, so next we will discuss the site pattern. Okay, so site pattern, for example, we will use a site pattern that will log, for example, the shipping information for the main application container. So how I will implement this? So first I will create one file with the site pod YAML name. So this will be the name of the pod. I will create one new file. So sidecar pod.yaml. So this will be a new file for sidecar pattern. So we'll see how it works. Let me clear the terminal now. Okay, so this is the definition of the sidecar pod. So here again, this is the basic information, version, and pod, what type of resource this is. This is a pod, and because this have a container, and one container or many container, and that share the same volume. So this is called pod, and it's a label sidecar example. And here you can see this YAML file, this pod have two containers. So this is the list that have two container. One is the main application container, and the other one is the sidecar container that will log the logs. or that will collect or process the log. Okay, so you can see I will define, I will explain. This is the main container, a name. This is it will use this image, Alpine latest image from the Linux. They will get that image, and this is the argument. Okay, so you can see here it will print this log information like with timestamp after every 5 seconds. It will print this message, and you can see here volume mount. So in the command argument, it will log the information to this location. You can see here they will create this directory var log app.log file. So this will log this information, and this is the mount information. Again, this is the share name of the volume is the share log, and the path, this is the path of the log file. And the sidecar container, name, image, same, they are using the same images. And this is the definition, like it will read all the log, and it will print the updates from this file. So this is the path of the file. Okay, again you can see here they are using the same volume. So this is the definition of the sidecar, and this thing will create one empty directory with share log, and this directory will use by both the containers. So this is the definition of the sidecar pod. Okay, so again I will deploy this pod. I will deploy. So kubectl apply deploy, and it's created. Once it's created, I will check both containers are running or not. So how I will get, I will run this this command, for example kubectl and get pod. It will give all the pod, and I will give a name of the pod, sidecar dash demo. Okay, so it will give information. So you can see here sidecar running, the state is running, and it has two container, two out of two is running. And next you can check logs as well. Okay, so this is the log information from the main container. And okay, so for example you can see here this is the log information, shipper, and follow sidecar logs. This is for follow side logs. This is the site they are printing from the main container. You can see here whenever entry comes to the site, the container, it also print the same thing. Okay, so so this is all about the sidecar container. Okay, so this is the information related to execute command specific container. So this is the execute command related to specific container. And okay, so this is all about the side, how you can implement the sidecar container. And again at the end I will delete and destroy. Okay, so this is deleted. Okay, so next thing we will discuss the init container. What is init container? Okay, so init container run before the main container started. It run before the main container started. So this is the main concept, and must complete before main container started. So this is the requirement for that. And I will show you this practically with the example. So again I will create one. Let's close this file. I will create new file, init container port example, and I will put some definition for this YAML. Okay, so this is the definition. Now I hope you will understand the YAML file definition. This is the basic configuration, basic definition, and this is the container specification. And you can see here this is init command. First init container that will create like a directory structure. So for main, why we need this, like for example the first container will set up the directory. So this will be responsible to set up the directory, and the second container will download the configuration, and the third one is the main that will read and print the created information. So this is all about this will create the directory, this will download, and this is our main application. And again they are sharing the same volume, that's why it's pod. And this is they are using, all three is using image, pull image from the Alpine latest. And this is the name, directory, the download, and it will make this argument show that it will create a directory, like for one is for the config, the other one is for data. And they will also create one file as well with setup.log. So this container will set up the main directory setup for the main application. The second one is the init container. Init container that will download the configuration. For example, this is a demo. So this is for now, this is just the database URL. So in actual application, you can download the configuration from any other source. But for now, this is the current dummy URL for database URL. And yes, it will they will use this file app.config. They will go there and they will put this configuration, and they will download and they will set up the log. And this is the main application. The main application will start, and they will do print this message echo start with a time. So this is all about the init container. Let's do some commands. So the first command is for this. I will apply to create the container. I will apply. So demo init created, pod is created. Now you can see there is one new command to watch the pod information. So you can see here, you can write this. You can when you put this watch, it will show the information. So they are showing that application started, directory created, and configuration also downloaded, and this is the information they are configuring. Okay, so this is all about the init container. Welcome to Practical Serverless and Microservices with C#. My name is Mohammed Abdullah, and I am Microsoft Certified Azure Solution Architect. This is session number 10, Kubernetes, and this is the part number 4, where we will discuss the storage and volume. So if you missed the first, second, third part of Kubernetes session, so please first check out the first, second, and third, then you can continue this part. So for learning objectives for this part is to understand the different type of Kubernetes volume. And we will discuss the empty dir, which is the temporary storage. Then we will create the persistent volume and persistent volume claim. And we will also work with storage classes for dynamic versioning and share data between container and pod. And at the last, we will implement data persisting strategy. Okay, so for prerequisites, you can watch the session number 1, 2, 3. Of this Kubernetes series. Then you have enough space in your local machine, as well as you should also install the Minikube and some basic understanding of the pod. Okay, so let's get started. Okay, so first we will discuss why do we need persistent storage in Kubernetes? Why we need storage? So the first reason is that the container are in peril. Like data is lost when containers start. So container does not hold or save the data. So it's like a volatile. When it's restart, the data is lost. So pod can be moved between from one node to another. And the third point is that application need to persist data beyond container lifecycle, and multiple container may need to share data. That's why we need the persistent storage. And we have different type of persistent storage. For example, we have different type of storage in Kubernetes. Like we have a temporary storage, like we use the empty dir for a single node. Then we have a persistent storage, which is a persistent volume with various backends. And if you have to store the secrets, we use the configuration secret. And projected storage combine multiple sources. So the first storage we will discuss is the empty dir volume, which is the temporary storage. And some information about the dir. When you create a pod, it automatically assigned to a node. This volume is automatically assigned when you create a pod. When you delete it, removed from the pod and shared between all the container. If you have a many container in a pod, this storage will be shared for all the containers. And storage stored on a node local store. So it is volatile. When it's restart or delete it, the data will be gone. So for a first exercise, practical exercise, we will create empty dir demo where we'll see how this work. Okay, so first of all, I will create one file, empty dir demo. So this is the file, and next I will add some code related to empty dir. So you can see here, this is the code. And again, this is the basic information, basic configuration, basic like we have a port, the metadata, a name, label, application, and this is the application container specification. So as you can see here, we have two containers. So it's a multi-container pod, okay, and we have one shared volume. You can see here, name of this volume is shared storage, and you can see here, this is the property we use to create empty storage. Okay, so the first container is using a lightweight Linux image, Elfin latest, and the name of the container is write. And what does this container do? It print message. Okay, after 10 second delay, they print one message, and to which file they are using this file. This file, you can see here, in this to this file they will print this message. And this is the storage, and this container will act as a writer, like it's like a producer. And the second container, which is a writer, that will act as a consumer. This is a consumer. Again, the name is writer, and reader is the name, and this is the image. Again, it will read all the data from this file. So the one is writing, the other one is reading, so nothing else. And you can say here, this is the volume, and this is the main point we are focusing in this video, is the empty dir. So about the empty dir, when the pod is started, this temporary shared directory is automatically created, and it exists on the node file system, and it shared by all the container in the same pod. For example, we have okay, so you can see here we have two container, and this volume is shared by these two, reader and writer container. So this is all about the empty dir. And when the pod is deleted or restarted, the data is lost. So this is the characteristic of this pod. So now I will deploy, I will create by applying this command. First of all, I will write kubectl, then apply f and empty dir dash demo.yaml. Remember that empty dir dash demo is the name of this pod, and when I run, it will create the pod. And if you want to get the running container, so you can use this command again, kubectl and get pods, and again the name of the pod, demo. So you can see here in this pod we have two container, and 2 out of 2 is running, and status is running, and the restart time is 0, and the age is 26 seconds. Okay, so this is how you can check the container status. And now I will write one command. I will check the logs inside the writer. ctl logs empty dir demo and reader. Okay, so you can see here, this is the logs of the reader, and it's reading data from the file. Okay, so next you can also specify the size for the empty directory as well. Like for example, you can for example, if you want to 1 gigabyte of space, so how you will do this, you will just change this empty to this one. For example, a name is a limited storage, and again the empty dir, and the size limit is 1 gigabyte. So you can also do like this as well. And similarly, you can also specify that I need space in RAM, not in the disk. So for this you can do like this. You can again you can use the empty dir and medium, and now the memory will be in memory, like it will store data in RAM instead of the disk. So this is all about the empty dir. So now we will discuss the persistent volume and persistent volume claims. So this is the two model we will discuss. So first we will understand the PV and PVC model. First one is the persistent volume, cluster-wide storage resources. It used for cluster-wide storage resources, and persistent volume claim request for storage by a pod, and storage class define a type of storage available. And this is different type of access mode, like a single node can mount read write in case of RWO, and the other one is the ROX, read only many, read write many, and read write once pod started. So this is the access mode. And now we will create one other practical example with manual PV, persistent volume, and persistent volume claim. So first here I will create one new file with manual PV -pvc persistent volume claim.yaml. So this is the file. Now I will put some code. Okay, so so this is the definition of the file. First one is the persistent volume, basic information, and the specification, capacity 1 GB, and access mode. You can see here I recently discussed this access mode. You can see here this is the list of the access mode, and this is the read write once mode, and this is the policy for retention, persistent volume reclaim policy, and name of the class is manual. This is the path, and this is the persistent volume, and the second one is the persistent volume claim, and it's in mode of the read write once, and this is the storage class of this persistent volume claim, and this is the pod. And first we created the, you can see here you can identify any resource by this kinda, like it's a persistent volume, and this one is the persistent volume claim. And the next we created one pod that have one container. You can see here one container, and it used the elephant latest image, and it will print this message persistent data to this file after 30 seconds. Okay, so you can see this volume. So the main difference between empty one is that you will use the empty dir keyword, and here you will see you can see here this is the name of the storage, and this is the persistent volume claim, so where which I defined in this in the second part. So and this is the manual PVC. So now we will deploy this PV and PVC to and pod together. So I will use this command kubectl apply manual PV-pvc YAML. So you can see here now three things is created. The first one is the persistent volume and persistent volume claim, and the other one is the pod, which is with name PV-demo. So you can get, how you will get the persistent volume. There is a command kubectl get like pod. This will be persistent volume. So here is the information. We have one manual persistent volume which is created. This is the capacity. We already defined the capacity, and this is the access mode, read write mode. You can see here read write once. We have this is the mode of the persistent volume, and reclaim policy status. This is all the information you about the persistent volume. Now how you will check the pod status? If, I'm getting pod PVC. So in the third you can see have three things created. So first I check the manual PVC and PVC, then I check the pod, which is the PVC demo, and it has one container which is up and running. And now I want to view the persistent data. So I will run this command. So you can see here this command will use to view the persistent data, and this is all about the persistent volume. So now I will delete this. We will delete the pod, but we will keep the PVC. So this will delete the pod. So, okay, now we'll see the dynamic provisioning with the storage classes. We will understand the dynamic provisioning. So dynamic provisioning, storage classes like define the storage type, and PVCs request storage from storage classes, and PV persistent volume storage are created automatically. So we will see this in action. Like first I will create one new file to see this example, dynamic PVC.yaml. So here I will add some code. Okay, so this is the code. The first one is the PVC with dynamic provisioning. Again, we have basic information, basic configuration, then specification, access mode, and this is the resource requested, and the storage is about 2 GB. And this one will use the default storage class. Because the storage class is not specified, so it will use the default one, and the default storage class is standard. So this PVC will use the standard storage class. And you can see here in the dynamic PVC persistent volume claim. Again, this is the basic information, specification. There is one container, and this is the volume they are using, name, and this is the location. And again, you can see here, this is the persistent volume claim. So I will apply, I will create this. So it's created PVC, and pod dynamic storage demo is created. And now I will get the PVC cube ctl get PV. So this is the PVC information. This is the PVC information. Okay, so you can see here, this one is we did not specify the storage class, so it is created with default one, and the other one is the manual because we specified. So this is the main difference between these two persistent volume and persistent volume claim. And this is how you can get the dynamic one as well. Like I will run this command to check the PVC status. Okay, so this is the status of the dynamic PVC. The capacity is 2 GB, read-write mode, and storage class is standard. So this is all about the dynamic provisioning. We will do a practical example in which we will see multiple node will share the storage. So for this example, I will create one new file, one new YAML, share storage YAML. So this is the storage. I will add code. Okay, so you can see this is the code for the shared one. Basic information, shared PVC. We created a shared PVC. Resource kind is the persistent volume claim, and mood, this is the mood, and the size, and this is the producer pod that have the container, and this container will print this message, and it's using the shared data volume, persistent volume. Okay, so this is using the persistent volume we created in the first step. And this is the consumer port. Again, this is also using the same persistent volume claim. So this will be shared between these two ports. And let's run, let's deploy. So first I will create this port. This is created, two port is created, one is producer, other one is the consumer. And I can also check pod and PVC together as. So this is the information related to the PVC and pod which is created, and pod is all the container inside the pod is currently running. So you can also get logs for the producer and consumer as well. Okay, there is no log yet. Let's check for the consumer. So consumer have messages, latest messages. This is the producer messages, and this command will check both port are in the same node. So you can see here both port are on the same node due to RWO, the access mode, about the access mode, and the consumer and the producer and the storage. Back to practical serverless and microservices with C#. My name is Abdullah, and I'm Azure Solution Architect. This is session number 10, Kubernetes. And this is part number 5 of Kubernetes. And if you missed the previous parts 1, 2, 3, 4, you can first check out those parts, then you can continue this part number 5. And part number 5 is about deployments and a replica set. What is deployment and what is replica set? We will discuss this in this session. So agenda for this, to understand the relationship between the deployment, replica set, and pods. And we will create and manage a deployment for a scalable application. And we will do rolling back updates and scale application manually, understand scaling strategies. And we will also use label and selectors effectively. So for prerequisites, you first check out the 4 parts, and the minikube should be running in your local system. And you should also know about some basic information about the pod and the basic Kubernetes concept. Now I'm in VS Code, so there is some basic definition. So we have a 3-layer architecture. The first one is the deployment that manage the replica set, and second we have a replica set that manage the pod, and at the third layer we have a pod. So we will create deployment practically in this part. So why we use deployments instead of the pods? So there is some benefits like the scalability. You can manage multiple replicas easily, and there will be a highly availability as well, automatically replacement of failed pod, and rollback updates. There will be like a 0 downtime deployments, and you can also easily roll back. And there is a declarative management. Describe desired state. Kubernetes handle the rest of this. So first of all, we will create one basic deployment structure. So for this, I will create one file, for example, basic .yml file, this file, and I will copy the code. Okay, so now this is the new thing, which is we check the pod, we use the storage persistent volume and persistent volume claim. Now in this session we are practicing deployment. So this is deployment kind of resource. Name is my deployment, and replica, we need 3 replicas, so I mentioned 3. And this is the selector. Labels, we will discuss label later. And this is the template, and this is the specification for the container. It will pull the ingress Nginx image, and that will run on this port. Okay, so this is a basic version of deployment. And now I will create another simple web server deployment. So I will create one new file that will use the Nginx image. So this is the name of the file is Nginx deployment, and this will be the definition of this YAML file. We have again deployment, name Nginx, deployment, version, and a replica. We need 3 replicas, and template, specification, container information, and this is the request and limit. Okay, resource request and limit. Okay, now I will I will deploy this application. First let's clear this terminal. Create it. Deployment is created. So how you will check, like pod pvc, you can also use the same command, kubectl get deployment, dep ments. So there is one deployment. Okay, and it's up to date, available too. Okay, let's try again. Now you can see here all the instances now are working. We have 3 things, and all 3 thing is up and running. So this is about the deployment. Now how I will check the replica set. How I will check the replica set, you can write this command, kubectl get replica set. It will give you all the replica set. It will give the information, desired 3, current 3, and ready is 3. Because I mentioned we need 3 replicas, so all 3 is up and running. This is the name of the replicas development. And again, if I want to check the pod, get pods, kubectl get pods. So this is all information. Okay, so this is all about the get pods. Okay, so this is all about the simple web server deployment. Okay, so if you want to get the detailed deployment information, you can run this command, This is the detailed information about the Nginx deployment, name, default. This is all the information, the detailed information of the you can also check the deployment rollback status by using this command, rollout status. So successfully deployment is successfully rolled out, so you can use this command. And you can also view deployment in a YAML file as well by using this command. So it will give you all the information in YAML file. So this is all about the simple deployment. Now I will back to the some information I wrote down. Now there is we will understand the labels and selectors. So how selector work? Like a deployment or selector to find replica. So with the help of deployment label selector, we can find out the replica set, and a replica set use selector to find prods, and label must be selector exactly. So this is some information about the selectors. So now there is one exercise working with labels where you can use, for example, view pod with labels. So you can use this command get pod show label, so it will show all the labels. So you can see here it showing all the label for you. And you can also filter pod by labels. So there is again this command that will filter pod by a label. So you can see here I add the filter ingress, so they will get all the ingress pods by this label. And you can also use you can also add a label to a pod, like for example, if you want to label any pod, you can use this command. You will just specify the pod name and which environment you want to use. So you can also add this label as well.